First of all, welcome to this training title on Ubuntu Linux. We're going to be learning a lot about Linux and how it operates. And I just want to tell you a little bit about myself. First of all, I've actually been using Unix and Unix-related operating systems for about 30 years now. I got started in, say, the mid-1980s, give or take. I've been using Unix for a really long time. I first started using Linux itself in the mid-1990s or so. I've got a lot of experience with Unix and Linux. I've been doing it for a really long time. I've been a security professional, information technology professional for about 30 years, doing a variety of things off and on over that 30-year time span. And I hope that you'll actually learn a lot about Linux, and I hope you'll get more comfortable with using Linux through the course of this series of lessons, getting you more familiar with the inner workings of Linux and the different functions and features of Ubuntu Linux specifically. So I hope you really enjoy this title, and I hope we'll have a lot of fun together learning and exploring Linux and its various capabilities. In this lesson, I'm going to just give you a brief overview on what you can expect. First of all, this is going to be very hands-on based, and we're going to be talking about Linux and various capabilities and features. And we're actually going to be using Linux. Just about everything I do here is going to be done inside of Linux. We're going to take a look at the desktop environment. We're going to do a lot of work with the command line shell. And I'm going to show you some of the capabilities of the shell and the command line, where honestly I think the real power of Linux actually is. Linux has a long history. It actually began 40-something years ago now with Unix that was created by AT&T. Linux is a nice little successor, behaves very similarly to Unix. And one of the features that it has is really the command line. And it's really where the power is, because that's where it started. And it was really designed as a programmer's operating system. And it's really designed to be very interactive on the command line and be very powerful in terms of what you can do very quickly and the types of things you can actually do by chaining commands together. So we're going to be talking about some of the features and capabilities of the command line. We're also going to be looking at the graphical user interface as well, the desktop environment that comes with Ubuntu. And we're going to spend a little bit of time there showing you some of the different programs that you can get with Ubuntu Linux and how you would install them. We're going to be talking about package management and installing new programs, where you would go about getting those new programs and how all of that would work. So get comfortable. I hope that we're going to have a lot of fun together by exploring Linux and its capabilities, and I hope you walk away with a lot more comfort in terms of what Linux is capable of and what you can do with Linux and how it's actually going to help you achieve the types of things that you want to do with your computer system. The first thing that we want to talk about is actually what's Linux? Well, Linux is an operating system, and it's got a pretty long history. If we want to go back to the very beginning, we should talk about Multics. And Multics was a time-sharing operating system that was designed initially with a lot of security and the idea that a lot of people would be using the system in mind. Multics was a joint venture between a number of organizations, including MIT, General Electric, and Bell Labs. Eventually, Bell Labs pulled out of the project. And when Bell Labs pulled out, some of the people who were working on the project decided that they wanted to go forward with something that wasn't Multics, that had different goals from Multics. And so they ended up creating Unix. And Unix has been around now for over 40 years. And Unix actually turned into a good operating system to teach the concepts of operating systems. It's a pretty modular operating system. It actually has very simple ideas built into it. And so as a result of that, there were several books that were written that used the ideas from Unix to create an operating system and actually teach operating systems from. One of those was called Minix. And there were some books written about Minix, and Minix was actually the foundation for Linux itself. Now, Linux was created as a result of Linus Torvalds starting with Minix as an entry point and making changes to create an operating system that would run on a PC platform. We call it an operating system. What Linux actually is, to be more specific, is the kernel. And the kernel is the piece of the operating system that actually interacts with the hardware, and it is the place where all of the programs that you as a user use communicate with in order to get access to the hardware to do things like actually putting things onto a screen, for example, or writing out to a hard drive. So we need that software to be able to work with the computer, and that's actually what Linux is. Now, there's a lot of different pieces of software that we load on top of Linux as an operating system, and all of that software gets put together in a particular way, and we end up with what we call a Linux distribution as a result of the way it's all put together. I mentioned that actually using Linux as a foundation requires a lot of software on top of it. And once you've loaded all of that different software on top of the Linux kernel, you've created what's typically called a Linux distribution. And there are a lot of different distributions. I just want to skim through some of them quickly to give you an idea of the different types of Linux systems there are available. DistroWatch is a great website that pays attention to all of the things going on in the Linux world and the different distributions that are out there. And if you go to DistroWatch at any given point, you'll see all of the distributions that are out and what the latest ones are. Right here, we've actually got a utility release. This is called gparted live. And you would use this if you needed a boot CD that was capable of doing disk manipulation. So I could do some partitioning, for example. Or I could resize partitions in order to do a dual boot. So I had, for example, Windows and Linux dual booting. I might need to resize my Windows partition to have space to put Linux on. Here's another distribution that's a pretty popular one. This is Fedora. And this is actually the open source version of Red Hat Enterprise Linux. This is where all of the development goes into, all of the testing. Basically, R&D happens in Fedora. And once they've got a stable platform and an idea of what's really going to work and maybe what doesn't work as well, that gets rolled into Red Hat Enterprise Linux. Here's another one, Scientific Linux, and we've got SME Server. Over here on the right-hand side, you can actually see the popular ones. And it looks like Linux Mint is, at the moment, the most popular distribution that's out there. That's followed by Debian and Ubuntu. And then following down, we've got Fedora, PC Linux OS, OpenSUSE, and a number of other ones. If we scroll all the way down, you can see all of the different versions of Linux or different distributions of Linux there actually are. And this stops at 100, and probably there's any number of ones beyond that. As I said, DistroWatch is a pretty good website for keeping track of the different distributions that are out there for Linux. In this particular case, we're going to use Ubuntu, even though at the moment maybe it's not the most popular, but in reality, Mint is based on the same platform as Ubuntu is. They both really get their foundation from Debian, which you can see is the second most popular at the moment. So we're going to get into actually creating an Ubuntu system coming up over the next several lessons, and we'll talk about all of the different ways that you can use it for, and we're going to talk a lot about how you can most effectively make use of Linux. In order to actually install Ubuntu, we actually need to go get a copy of it. I'm going to go to www.ubuntu.com, and that's going to take us to the Ubuntu website. You can see it's got a number of different versions here. There's actually a cloud-based version, so you can create your own private cloud. There's a server version, and there's the desktop version, which is actually what we're going to end up using here. Now, Ubuntu actually generates 2 different versions in any given year. So we end up with an April release and an October release. So every 6 months, they are releasing a new version of Ubuntu. You can see just skimming through here the different features that Ubuntu has and explains why it's free and it's backed by Canonical. You can get an online tour. There's a community where you can ask information about Ubuntu as well as asking for help. So we could go to Ask Ubuntu and get help about the distribution and places where you may be stuck about some things. There are mailing lists, there's a blog, and there's forums. So there's a lot of support for Ubuntu, and if you ever get stuck, you can certainly jump onto the website, jump onto the different places where you can get additional help with doing some things that you want to do. Now, in order to download it, we're just going to download here. And I'm going to click on desktop because we're going to use the desktop for this. Now you can see that we've got the 1204 LTS, and long-term support is something where they actually expect to maintain this for a long period of time. This is the April release from 2012. This is a long-term support release, and you can see that they expect to guarantee updates until April 2017. We've got the October 2013 release, that's the 13.10 here, and they say that they're only going to support that for 9 months. That includes cutting-edge new features that make music, video, documents, and apps much easier to access. So we're actually going to use the latest release here to do the install. You could, if you felt more comfortable, use the long-term stability or long-term support release, and it's going to work just as well for you in terms of what we're going to be using. There may be some differences in versions for the packages, but that's not really that big of a deal. So you could download the 12.04. I'm actually going to download 13.10 here, and that's the one that we're going to install. And we'll get around to walking through the install coming up next. I'm going to boot into Ubuntu at this point, and I'm actually going to do this inside a virtual machine. Running it inside a virtual machine actually works pretty well, and the virtual machine that I'm using here is Parallels, and Parallels integrates pretty nicely with Ubuntu. It actually has the ability to do some different things in terms of integration of the mouse as well as video, so it actually integrates pretty well into your desktop. So I'm just booting up here, and it's going to ask me the language. I'm just going to say English, and there's some different things that I can do here. Once I've got the boot menu up, I could try Ubuntu without installing. I could install Ubuntu. I could check a disk for defects. I could test memory, boot from the first hard disk. What I can do, though, is I can actually try Ubuntu without installing, and this actually is making use of a feature that's typically called a live CD. I've booted from a CD, or in this case, it's actually a DVD, but I've booted from this disk, and I can actually run the operating system without ever installing it to the hard drive. The downside to that, of course, is actually I can't write out permanent changes to the disk without involving a disk in some way. What I'm going to do here is I'm just going to try Ubuntu without installing it, and that's going to boot up to a live CD environment, and we'll take a look at that live CD environment actually when this finishes booting. I've booted up to the live CD at this point, and this is pretty much what an Ubuntu desktop is going to look like. The problem that we've got here is that the CD doesn't accurately reflect what the resolution is, so this is actually smaller than what we would get once we do the actual install. However, we can see what's going on here. I can see I've got some icons down the left-hand side. I've got Firefox, for example. You can just click on that and I'll be launching Firefox, and I'll have a browser so that I can do some web browsing. I can go to, for example, ubuntu.com here, bring up the web page. And I've also got in the live CD a word processor, a spreadsheet application, and then I've got a presentation application. I've also got access to Amazon, and of course here I've got some system settings, and I could go change a lot of system settings in terms of the way the desktop looks, and might be able to change the actual resolution so that we were able to see it better. But we're not going to stay here for very long. Just wanted to show you that if you wanted to just try Ubuntu, you could actually boot up to the live CD, play around with it a little bit, and you would have a working version of Linux, and you wouldn't have to spend the time doing the installation. If you remember when I booted up, actually, I had the ability to do an install at boot time, and I could certainly do that. I could go back and reboot now, and it would actually give me the opportunity to do an install just from boot and not worry about being involved in the desktop. Now, what I could do is I could boot, I could do the install. What I get from the live CD, though, is the ability to install while still actually using Linux. So I've got my live CD environment. I could run an install at the same time and still be able to use this live CD environment to browse the web, to look up information about the installation that I needed while I was doing the installation. So I've got a lot of capabilities here which are really helpful, and it also gives me something to do while the installation is going on. It's reasonably quick, but it's not like it's over in just a few seconds. So if you're easily bored, you can still sit and play, browse the web, whatever, while you're doing the installation. So in this case, rather than rebooting and going through the install there, all I'm going to do is install Ubuntu from right here. So I'm going to launch the install, and it's going to bring up basically a wizard to walk me through the installation process. At this point, I'm in the installation, and I've got my welcome screen up. It's asking me to choose a language that I want to use, and I've got a lot of different languages. I happen to speak English as my primary language, so that's what I'm going to select, and I'm going to continue there. Now it's going to actually check and see whether you've got the minimum requirements. So I've got at least 5.9 gigabytes available for disk space. I don't happen to be plugged into a power source at the moment. I'm running off my battery on the laptop, and so it's actually telling me that I'm not plugged into a power source, which could be helpful. You don't want to get partway through an installation, have your laptop die, and now you've got a failed installation and a disk that's really in kind of an odd state. You would have to completely start the installation over again. I could download updates while installing, and in this case, I'm going to allow third-party software as well. We'll continue on to the next page of the wizard. You can see down at the bottom what our status is, how far along we are. So far, we're 4 pages in, and at this point, we're going to talk about doing the disk creation and how you would go about partitioning the disk. Here I've actually got some things that I need to consider when I'm doing the installation. And what we're at is the disk partitioning state. And what it's asking me here is whether I want to erase the disk and install Ubuntu. In this case, I've got a blank disk. That's exactly what I want to do. I actually have the ability to encrypt the installation, so I've got encrypted files on the hard drive. And I could also use Logical Volume Manager, and I'm actually going to turn that on. Logical Volume Manager actually gives me the ability to have additional drives where I can add those drives into a logical volume and create a volume that's bigger. So basically, with Logical Volume Manager, I can keep adding hard drives, or in this case, virtual drives if I wanted to. I could add virtual drives to the system, and I would create one large logical volume out of that, rather than being limited to just the size of my physical disk. If I were working on a real system, I could install multiple physical disks, use Logical Volume Manager, and create one large logical disk out of those multiple physical disks. So I'm just going to say I'm going to use Logical Volume Manager, and I'm going to erase the disk and install Ubuntu, and now I'm just going to click Install Now. At this point, it's going to go and install the various packages once we've gone through a couple of other things. It's asking me where I am. I'm just going to select the Eastern Time Zone, and we should have a couple of other questions here based on the status down here, and it's asking me about my keyboard layout, so I'm going to say that's English. I don't use a fancy keyboard layout like Dvorak, for example. And now it's asking me about a username. So before we actually go install the software, it wants me to set up a user account, and I'm actually going to talk about user accounts and how that works coming up next. I'm at the stage in the install where it's asking me to create a user account. This is actually a pretty helpful thing to do. Once it's rebooted, it's going to require me to log in, so I really need a username in order to be able to log in. Now, by default, Unix and Linux have what we call a super user account, and that's called root. It's really insecure to use root on a regular basis because it opens the door to anything that you do now has super user privileges. So if you go to a malicious website, for example, you could have malware installed and that would be running as root. Or you could have a piece of software that you're using that has a vulnerability in it. There's an exploit that's available. Now your system has been compromised. So what we do here is we actually create a user account, and then from that user account, we'll actually have the ability to do things as a super user as we need to. And I'm actually just going to change the name of my PC here. I'm just going to call it Rosebud, after Rosebud the Basilope from the Bloom County cartoons. And I need to pick a username. That's my username. Now I'm going to plug in a password. Now I could log in automatically, or I could require my password to log in. And I also have the option here of encrypting my home folder. I'm going to require my password to log in, and now I'm going to click Continue, and it wants me to have a Ubuntu One account, so let me register later. And at this point, it's going to go off and do the install. You can see we're installing the system, and I'm a little busy right now, but based on my cursor, I could click on that and see what it's actually doing, which is in really small print, so it's not going to be particularly helpful. But it's going to go off now. It's going to do the installation. It's going to put all of the software that it considers to be a base installation on my system, and then it's going to go and reboot, and we'll have a system that's actually ready for use. Once we're rebooted and we're back up and running, we'll walk through a little tour of the desktop and see some of the features of the Ubuntu desktop. At this point, we've got our system installed, and this is the desktop here. Now, Ubuntu uses what's called the Unity desktop, and it's based around the GNOME desktop environment. And this is really what it looks like here. You can see Ubuntu desktop, and this piece up here is what is typically called the panel. Now, in previous versions of the desktop, you could add different things to the panel. Currently, you can't just click on it and add anything, but there are a number of components in the panel already here. First of all, we've got the ability to make some changes to the keyboard, so you could change the character map, for example. If you wanted to change your character map so that you're using maybe a different font, or you're using a different alphabet set or character set, you could change that here. I could also change my keyboard layout. Currently, I'm using an English US keyboard. I could actually make some changes to that from here. I could change text entry settings. Now, here next to it, we've actually got some network information. You can see that I'm connected via my wired connection, or what it thinks is my wired connection. I could disable networking here. I could set up VPN connections. This actually shows my availability. So right now it's showing me offline. I could select available. I would be online then. We got my battery status. I could show percentage in menu bar. And typically here we've got the volume setting, which is pretty common. We've got the time and date right here. This is almost like an Apple menu, actually, where on the Mac OS, you've got in the upper left-hand corner, you've got the Apple. And this is similar to that. We've got About, we've got Help, and we can get to System Settings. I can also log out, suspend, restart, and shut down from here. And I could lock the desktop. So I could do that. And then I would have to log back in here to get back there. Once again, we've got our desktop here, and we've taken a look at the panel. I want to take a look at this part over here, which is the dock. And the dock is already pre-configured with a number of tiles here, which are really application launchers. I'm going to start at the bottom. You can see the trash there, and I could click on the trash and just take a look at what's in it. You can see all I have to do is single click, or actually you can't see because you can't see what my hand is doing, but all I had to do is click this once and it brought up the trash. Now, above that, we've got the software updater, and I noticed that there are some arrows here which indicated to me that there was actually something there that I wanted to take a look at. And you can see I've actually got some updates that I should probably install. I'll take care of that a little bit later on. Right now, we've actually gone away from the updater because now it's just system settings. And you can see I've got all of the system settings. Down here, I've got software and updates. And if I click on that, it actually takes me to a configuration box where I can change where I'm getting the software from. I can take a look at the updates that I'm getting, whether I'm getting security updates, recommended updates, unsupported updates. I could also get pre-released updates here. So I've got access to all of my system settings, and we'll take a look at system settings in a little bit more detail later on. I've also got Ubuntu One Music. I've got a link to Amazon. I've got a link to Ubuntu One, the Software Center, and here's some Office software. So I've got some presentation software, a spreadsheet, and a word processor. Now I've got my web browser, and I click here and I've got my file manager, which is just an Explorer-like thing where I can see all of the files on my system, and I've got a user interface here for getting access to the files that are on this system. Now, this is almost like a start menu, but it behaves a little bit differently than you would expect a Windows start menu to. If I click on it, the first thing that pops up is I could search my computer and online sources. And there are a lot of other features here that we'll take a look at shortly. But this is sort of like a menu button, and this is how you might get access to your applications, for example, or you might be able to search for files. We've taken a look at the panel, and we've taken a look at the dock over here. Let's take a look at how you would actually go looking for applications. Obviously, not everything that I want to get access to is over here or would even necessarily fit over here. So I'm going to want to be able to get to programs that I want to run. Now, the quickest way to do that is just click here on the button at the very top, and I'm going to get to Search Your Computer and Online Sources. Well, I happen to know that I've got this LibreOffice writer, so let me just take a look for Libre. If I just search for that, it's going to bring up LibreOffice, Office Calc, Office Impress, Office Writer, and Office Draw. Those are my applications. I can also do a lot of other searches, so we've got suggestions here for various things that are in a store, for example. There are references, and we've got some graphics. So it's gone out and done a web search for some different types of files and features that actually match this word here, Libre. What I was looking for, though, was applications. So let me just close this. Now, another way to look for programs is, you can see down here there's this A. If I were to click here, Then I could see recently used, I could see the results of all of the applications that are installed here, and I can get quick access to all of them. So this is sort of like the Windows Start menu if we didn't actually have a folder way of organizing it. This is all of the applications that are installed. As we install additional applications that are graphically based, then these will show up here. Now, these obviously aren't all of my applications. These are just the ones that are graphically based that have icons and quick launch buttons for them. There are a number of other applications that I can get access to from the command line, and we'll certainly be talking about the command line in a fair bit of detail later on. But I wanted to show you how you could get to the graphical applications, since those are the ones that most people are most comfortable with and most familiar with. Those are going to be where you're going to spend a lot of time. You're going to be spending a lot of time in your mail, potentially. Certainly, you're going to be spending a lot of time with your web browser. And this is how you get access to those. So there are games here as well. We've got some system configuration. And of course, we've got LibreOffice, which are the Office applications that are installed on here. So again, in order to get to where you can look for applications, you're going to click this button on the top. You can either start typing here and it's going to pop up results that match what you type, or if I go down here, I can click on this A and it's going to show me all of my applications. And again, we've got the recently used up top and the installed, and I can filter it a little bit more and just show basically the top line there. Or I could click on it again and show all of my applications. That's how you would get to applications, again, that are graphically based, that have icons associated with them. And again, we've got a lot of other applications that are command line based, and we'll get into those a little bit later on. Now we've seen how to get to the applications, let's talk about running them. And this is really going to be an easy thing, and we'll just walk through this pretty quickly. Again, we've got a number of applications that are over here, and if I've got something in the dock here, all I've got to do is click it once. And the application opens up. So now I've got my file explorer here, and I can start clicking through here just like any other graphical interface that you're used to. And here I've got the Firefox web browser. So if I click that, again, all I have to do is click it once if it's in the dock over here, and it's going to launch for me. And then I can do all of the usual things that I do, and it behaves just like any other graphical desktop environment that you're used to working with. We've got some things that are maybe a little unfamiliar, but once you get used to them, it's going to behave more or less the same as most any other graphical environment for you. Again, I could do a search. Let's say I want to run the terminal, and this shows up in my applications here because it's one, I guess, that Ubuntu thinks has been run regularly or is going to be one that I want to run regularly. I haven't really done anything with this desktop here, so this right here that you're seeing is really Ubuntu's guess in terms of the ones that are going to be seen the most often. And the reason I say these are the ones that Ubuntu thinks are the most used is if I go over here, it actually says recently used. And the fact is that I haven't used any of these other than the audio mixer. When I was playing around just a couple of minutes ago, I clicked on audio mixer by mistake and that popped up. So that does show up as recent. The others are really Ubuntu saying these are ones you're going to probably use a lot and want to get to quickly. One of them is certainly Terminal. Again, all I had to do was single click it just like you would in any other menu-based launcher of graphical programs. So I single clicked it. Now it shows up down here in the dock because it's running, and you can see I've got the arrow next to it indicating that that's actually a running program. And if I were to take the mouse away, you can actually see it collapse there to make some space for everything else that's in my dock over there. And again, if I want to close it, if I come up here to the very top, again, this is very Apple-like, where the menu for the application is always going to show up in the panel on the top of your desktop. So I could get to the file menu here and I could close the window. I can do the edit functions. What I'm going to do is I'm just going to click the X here. Unlike Mac OS, where you actually have to close the application and not just the window, you can see that actually the application is gone. It's no longer running. So all I had to do was click the X at the top and the application stopped running rather than just closing that single window there. Again, if I want to get to one of these, let's say I want to run Thunderbird Mail, because that shows up under something that you want to run on a regular basis, or at least Ubuntu thinks you want to run on a regular basis. So let's just run that. All I have to do is single click it. I get Thunderbird Mail. It's going to pop up and probably ask me for some configuration settings, which is actually exactly what it did. Again, if I want to close these things, there's the X up there. I can just click the X and I've closed the application. So that's how you would go about running graphical programs. One of the things you probably want to do when you're working with this is you probably want to make it look like you really want it to look. People like to customize their desktops so that they're comfortable with them, they enjoy how they look, and behave in the way that they expect them to behave. So in Ubuntu, I can make some changes to the desktop. All I have got to do is go to System Settings over here in the dock. We're going to bring up the System Settings. I can change the appearance here, for example. I could change my background, put some different wallpapers up. I could change pictures. If I had pictures on here, I could do colors and gradients. So I could go back to just the color that I want. Let's just pick a simple color here. I'm going to select it now. I can go to this particular color and I can change the launcher icon size, for example. I could make it smaller. You can see they shrink down. I could make them bigger. They get a little bit bigger. And when I'm changing the slider here, what you should be looking is on the left-hand side, the icons are actually shrinking. I can change my theme. So I've got ambience, which is the default. I could change that to radiance. You can see everything kind of changes a little bit. And I could change the behavior so that I could auto-hide the launcher or the dock on the left-hand side. I could change it to be the top left corner if I wanted to, where it gets revealed. I can do the workspaces, so I've got multiple workspaces potentially. You see I get a little box down here on the left-hand side where I could change workspaces. So basically this is virtual desktops. So there's lots of different things that I can do with customizing the way that my desktop looks and behaves to a certain degree. I could go back to all settings. I could change brightness, for example. If I've got multiple displays, I can do that. And there are a number of different settings. Again, just like Mac OS, just like Windows, where you've got a lot of control over how your system looks and behaves. I've got the same thing here with the Unity desktop, where I can change language support and add hardware and so on and so forth. And again, we can change a lot of the way that the desktop looks and feels, so it's something that's appealing to us, and we enjoy being in front of the computer and working at it. It's visually appealing so that we're a little bit more comfortable actually sitting in front of the computer and doing work and playing with it. We're going to take a look at some useful utilities now. There are a number of utilities that get installed just by default with Ubuntu that are going to be really useful for you. And I'm going to take a look at some of the graphical ones just really quickly here so you can get started on some useful things that you may want to do. The first one we've actually looked at a little bit here is just the File Explorer. It's a pretty common look, and we've got recent places over here. We've got Home, Desktop, Documents, Downloads, Music, Pictures, Videos, and Trash. I've got all of those over there. I've got Devices, where I've got my computer. I've got my Home, which is actually connected to my host operating system since I'm running this inside of a virtual machine. I could browse the network, for example, and you can see some different systems that are showing up there. So the File Explorer is actually pretty useful. And we've got the Software Center here, which is where you could go searching for software. And we'll take a look at installing software a little bit later on, but this is a pretty helpful utility as well. Certainly what comes installed by default with Ubuntu is really good and will get you started in terms of some things that you want to do, but invariably there's going to be additional software that you want to install. There's tons and tons of software that's out there you can install very quickly and easily, and we'll get to doing some software installation a little bit later. The terminal we're going to be spending a fair amount of time in. I think, to me, the command line is where the true power of Linux actually is. There's a lot of capability that you can make use of on the command line, things that you can do that you can't do nearly as easily with a graphical interface. So we're going to spend some time with the command line in the terminal here. Of course, there's mail. You can take a look at your videos. There's text editor, calculator. Of course, all of those really useful. If we go down here, we could get to the different settings, for example, directly from here. We've looked at appearance previously. We could do an application finder, so I could more quickly and easily find applications that I'm looking for example. It looks like that's going to take some time to come up, so let me see about coming over here and finding some other ones. I could use a bulk rename. It's a really useful utility. So if I needed to change a lot of names very quickly, I could do a shift click there just to show you the selection process. But I could actually change the names, I could insert times, I could change the format. There's a number of different things that you can do. So if you've got a lot of pictures, for example, and they come in with DSIM some number for the file name, you could actually change them all to, say, Christmas, and then have an incremented number with the time or the date or something like that. So bulk rename takes a lot of the work out of renaming files for you. And you can go back over here to the applications. You can see these are just the graphical programs that have been installed here. We've got the font viewer, for example. We're going to take a look at the Office applications a little bit later on. And we've got a remote desktop client. So there are a lot of utilities here. And of course, there are some games as well. There's Sudoku. And again, we've got a number of graphical programs that have just been installed by default, and certainly we'll take a look at some additional functionality by adding software a little bit later on. We're going to take a look at the Office utilities or Office applications that come installed by default with Ubuntu. We've got LibreOffice, and we've got all of the programs that you would expect to see in an Office suite. So here's the Writer, which is your word processing software. And it looks an awful lot like you would expect a word processing software to look. So we've got styles, we've got fonts that we can change, we've got font size, we can print directly, or we could do a page preview. You could export directly to PDF. And of course, if I want to do new, I could do open here as well. Again, we've got all of the functionality pretty much that you would expect to see from your standard word processing program. So I could, just start typing here. And if ready to save it, I could do a save. Lets me save. So pretty standard word processing document, right? Let me close that without saving because I don't need it. So I'm going to open up Calc, which is the spreadsheet. Again, pretty basic. I could do equals sum, for example, equals sum. Just like I could with any other spreadsheet software, I can do functions and so on. I can just start typing numbers in here. And so now down here, let me do average. So I've got an average there. You can plug some more numbers in. So pretty standard spreadsheet software here. If I were to do numbers here, it adds them up for me over there. So I've got the same things. I could save, I could open, I could create a new one. Again, pretty standard functionality. Great thing about this is it's actually free. So I've got my spreadsheet software, and let me open up my presentation software. So keep in mind that with some of these, I've actually got a menu up here, even though when I come down here, it disappears. If I bring my cursor down into the document, my menu disappears. All I've got to do is drag my cursor up to the menu bar here, and it becomes actually a menu bar. I can have a lot of documents open, and they're really all open in one LibreOffice, but I've got a lot of different types of documents that I can open in the same thing. So if I were to exit LibreOffice, even though I've got this presentation here open and I've got the spreadsheet, once I close LibreOffice, both of them go away because it's one application that has multiple views, really. Now, I've got my word processor, I've got my spreadsheet, and I've got my presentation software. I've also got a drawing program. So I've got a program that I can actually create pictures with. So let's do that, and I can draw shapes and so forth. It's not as fully featured necessarily as other programs that you may be familiar with. But in terms of price, it's certainly much cheaper than, for example, Photoshop or one of the other ones that you may be used to. So I can draw some lines here. Let me draw another line. So I can do some things here that I can create some pictures, I can edit some pictures and so forth. So I've got Draw and I've got the other Office utilities. So I've got a pretty fully featured Office suite that just comes installed by default with Ubuntu. So you've very quickly just got a reasonably useful desktop right here in front of you. Okay, let's get talking about using the terminal. I've mentioned the terminal a few times. I'm actually just going to click it open here, and we've got ourselves a terminal. Now, if you're not familiar at all with the terminal, you may not have seen it if you've done work with macOS or with Windows. Those operating systems tend to hide some of the functionality that's in the terminal by giving you graphical ways of doing it. You still have the ability to use a terminal or a command prompt, whether you're using macOS or whether you're using Windows. The foundation of Linux is Unix, and Unix early on was a command line operating system. So a lot of the core functionality is still in the terminal. So I've got my terminal here, and actually let me zoom in so we get to be a little bit bigger. Picture's a little bit better here. Let's say I did something like catting out a big file, for example. I could search within my terminal here, which would be really helpful. So let me just cat and see if I can find. So I've got a file that I just printed out to the screen, and then I did a find in my terminal, which can be really helpful when you're looking for some piece of an operation that you performed and you've got a whole lot of text on the screen. Having the ability to search can be really useful. So I've got some things I could actually close the menu bar, I could zoom in, zoom out, go to normal size, I can change my profile. So let's take a look at the edit here. I'm going to use the system fixed width font, and selecting by word, it's going to use these if I wanted to select, for example. Let me close this down. If I double click, it's looking for a space, so all of these things, even with the colon and the comma, are going to be considered just part of the word. So let me do that. If I double click that, I've got MDNS as my word, and I can do a select by word. So I could change how I select that by going into the profile there. And these are the characters that would be allowed to be part of a word. I can change the title, say my terminal. So the initial title says my terminal. Eventually, though, it changes over to, let me close it here. You can see my username at the host name, and then the wiggle here suggests that I'm in my home directory. If I change the directory I'm in, the title bar changes. So I always know what directory I'm in by looking at the title bar. I also know who I'm logged in as because I can change my user in the terminal as well. I could do a sudo su, for example, and become root. And now it shows up here that I'm actually root. So anytime my command prompt changes, my title bar actually changes along with it. So we're going to be doing some things with the terminal through the course of the next several lessons up until pretty much the end. We're going to keep coming back to the terminal. And I just wanted to show you very quickly how to get into the terminal and what it looks like. So we've got a little bit of familiarity with it for when we actually start doing some real work with the terminal. I'm going to show you now how to do some customization of the terminal. And what I'm going to show you is just a temporary thing, but eventually we'll talk about how to make permanent changes to your terminal session. One thing you may want to do is actually set up some shortcuts for yourself. Often I'm going to do something like ls minus la, and ls is just list, so it lists the files, and minus la says a long listing and all of them. So these are the parameters for the command ls. I'm going to type that an awful lot, so maybe I really want to make a shortcut for that. Well, I can use an alias command and say ll equals ls minus la. Now, if I do ll, I get basically ls minus la. Now, I can also do rm asterisk, which says delete everything. And that's a pretty common mistake that people make sometimes, is typing rm asterisk and deleting everything without realizing where they are and all of the files they're going to be deleting. So a pretty common alias sometimes is setting rm to actually be equal to rm minus I, meaning it's going to ask me. So now if I do rm asterisk, it's going to say, do you really want to remove that? I say no. And of course, it's not going to remove the directories because I need to do rmdir in order to be able to remove a directory. So I've got some ability to change what I want to do. So if there's something I'm typing an awful lot, I could say t equals top. Now if I type t, I'm going to get top. So I can set up a lot of aliases for myself that save me some typing. And of course, one of the things about Unix or Linux commands is they tend to be really short. But when you start chaining them together, you end up with a lot of typing, and you may want to set aliases for a number of things that you're going to chain together. And we'll talk more about chaining commands in a little bit. But when you start getting into really the power of the command line, you're probably going to want to set some aliases for yourself. And knowing the alias command is really helpful because you can set up these shortcuts so you can save yourself some typing. Let's talk about running programs from the command line. Now, you've actually seen me do that. ls is just a command, so it's really a program that I'm launching, and all I've got to do is type the name, and it runs the program. Now, I can do that also with graphical utilities, so I could run Firefox, for example, and it brings Firefox up. What happens, though, is I can't actually type anything else in the terminal while Firefox is up because it's waiting for Firefox to complete. So let me close this and get my command line back. And it queued up all of those things that I typed, so when Firefox completed, it's actually trying to run all of those. Now let me just clear that out. So what I did there was I just cleared the terminal to get some of the clutter off the screen. I can type clear anytime, brings me to an uncluttered, clear terminal. One thing I can do, if I wanted to run Firefox from the command line, is I could say Firefox ampersand. And what the ampersand says is send this program here to the background. Now, with a graphical interface, there's really no such thing as foreground and background because it's constantly running because it's really interrupt driven. So I could run Firefox here. Now I can go back because I've sent Firefox into the background from the standpoint of the terminal, but I've actually got my terminal back so that I can go back here and do things. And Firefox is still operating. I can just go to google.com and it brings up Google. So Firefox still is working completely functionally. And I could open up LibreOffice, for example, and have another one that's running. And now I can just come back over here, get my terminal open, and I've got my terminal back. So let me just close this out. And now when I hit enter, my terminal indicates to me that LibreOffice is done. So it's saying that the process that I launched from the terminal has actually completed. So that's one way of actually launching programs that are graphical in nature. Isn't necessarily limited to doing the launch bar here. You can actually come here and launch your program. So I could do LibreOffice, and you'll notice that that popped up pretty quickly. One thing I can do with the terminal is I can use tab, and tab will complete commands for me. So I hit tab here. It's telling me that there's a couple of things I could do. So if I type R and then hit tab again, it completes it for me. Tab completion is really powerful, really helpful when you're typing a lot of things. I can also do something like this. So it's not just commands, it's sensitive to what I'm actually typing. So it knows where I am and what I'm doing. And if I type DE, for example, it knows that there's a directory called desktop. I could do something like TO, and the first time I hit tab, it doesn't do anything. What that tells me is there are a lot of options that match that TO. If I hit it again, now it pops up all of the programs that I could actually launch that start with TO. So I've got TOP, I've got Totem, Tosh, Set, Touch, and so forth. So command completion, really important. And again, I can run graphical programs from the terminal just as easily as I can. I just have to remember if I'm going to run a graphical program, because it's going to launch and just run. If I want to get my terminal back, I need to finish it with an ampersand, which just says, go to the background. And with a graphical program, since it's interrupt driven, being sent to the background is not really a big deal. I could, for example, do top and send it to the background. And in order to get back to it, because it's just kind of sitting there now, because it's a terminal program, if I do foreground, now it's saying it stopped. And that's because it didn't like being sent to the background because it didn't have a way to interact with the terminal as it was supposed to. So there's a lot of command line programs I can send to the background, and they'll just kind of hum away. So if I were to do a long program compile, for example, I may want to send it to the background while I'm doing some other things. So far, we've been using the Unity desktop here. Now, I could use a different desktop environment. There are actually several desktop environments that are available for Linux. I've installed an additional one on top of the one that just comes installed by default. What I'm going to do here is I'm just going to log out. And so it's asking me if I want to log out. I do want to log out. And what I want to do now is I actually want to change my session. So I'm going to click that button there, and I'll take it back in just a second. So I'm going to change to an XFCE session, and now I can log in, and you can see the dot that's right next to my name, and that's the button that I click to select my session. So if I log in at this point, now what I'm going to get is my XFCE session, and I'm just going to use the default config. And you can see my desktop session is now different from what it was before because, of course, I changed the session type. I can install other desktop sessions or desktop environments, and I can change the environment that I'm working in just simply by logging out, changing the session that I'm using, and logging back in. In this case, I'm using XFCE. I was using Unity previously, and there are a number of others. There's KDE, for example. Mate and Cinnamon, for example, are both used in Linux Mint. And there are a handful of other desktop environments that you might use, in addition to the couple that we've seen here. Now, I just showed you very quickly the display manager. Let me go back to that. I'm still in the XFCE session that I jumped into. So I'm going to log out here, and we're going to go back to the display manager. there are a handful of display managers that you might run across. This one is the display manager that comes installed by default. As I said, there are a handful of them. There's the display manager for KDE. There's XDM for the X display manager. There's GDM for the GNOME display manager. There's also LightDM. And you've got some capabilities here. So I've got where I can change my session. I could do a remote logon here if I wanted to. I could do a guest session. I can go up here and change some of my capabilities around accessibility. So I've got an on-screen keyboard, high contrast, or a screen reader. I can change my networking. I can change my keyboard. And of course, I've got, battery, sound, and the date and so forth. I can also use some power functions, so suspend and restart and shut down, for example. Normally what you're going to do is you're just going to log on. And actually what I've got my system set up to do is to auto-log me on, because really I'm just using this virtual machine for doing this set of videos and doing this training. So I'm not really worried about other people coming up to my system, booting it up and getting in as me and doing things. You can actually set it up to auto-log you in if that's what you want to do. That's something that I did at the point where I was doing the install. And as I said, you can log out anytime you want. If there were other users on here, I could log in as other users. My user happens to be the only user that's on here. And of course, I can just log in, and I'm going to make sure that my session is changed to be the Ubuntu default, which is the Unity session that we've actually been working with so far. In this lesson, we're going to be talking about getting help. Now, there's one quick and easy way to get help. If I come up to this button here, you'll see help right there in front of you. I can click help, and it's going to bring me to the desktop guide, and I can click through here and get some help on using the Ubuntu desktop. Where I want to focus my time, though, since with some of these graphical things, you can kind of click your way around and more or less figure out where you want to go and what you need to do. If you do need help there, certainly there's help that's available. Where I want to spend a little bit of time, though, is some of the capabilities from the terminal for getting help. That's where a lot of people really get stuck. Now, if I want to do something just like list files, I can do ls. What if I wanted to know what types of command line switches or parameters that I could use with ls? Well, one thing I can do is just do ls-help. -help or -h works with a lot of the command line utilities that you're going to end up seeing and using. Not all of them, but many of them. Another thing you can do to get help is to just man ls. Man is short for manual pages, and this goes back to the days of Unix where there were a set of manual pages that came in a number of sections. And so to this day, actually, you'll see these categorized into sections. In this particular one, the section is 1, and there are, if my memory serves me correctly, there are 6 or 7 sections, and they focus on different things. So there's system utilities, there's programming functions, and you could do things like, I could do man 3ls, for example, if I wanted the third section as opposed to the first section. In this case, there isn't a third section, so I wouldn't get it. But I can specify which section I want if I happen to know that the same keyword is going to come up in multiple sections. So sometimes you'll get something like open, for example, which may show up in a couple of different sections, and one would be a command maybe, and one would be a programming function. Certainly there are programming functions along those lines. So several different sections in the manual pages, and you can get access to those just by specifying which section you want if you've got something that's going to come up in multiple. Now, something else I can use is info. Now, info is a little bit different from man in that I can actually manipulate this more directly than I can with a man page. So I could go to Here, for example, I arrowed down to where it said ed, I hit enter and it popped me down here. Now I can go arrow down to this section here. This is another jump that I can go to a different page with. So now I'm going to go to intro to line editing. So info is actually similar to man, except that it's more directly interactive, where I could do man ls, and all I can really do is go up and down. I'm just using the arrow key here to go up and down. I could hit the space bar because what it's actually doing is it's using a pager to display specially formatted files. So we're rendering the specially formatted file and running them through a pager. And I'll talk a little bit more about pagers coming up, but what a pager really is a program that chunks up a large file into smaller chunks that will fit on a page. So I can go backwards here to the beginning. If I hit spacebar, I'm going to get the next page. Hit spacebar, I'm going to get the next page. I type B, I'm going to go back a page, and so forth. So this, all I can really do is look at. I can't go down and touch one of these or hit enter on anything and take me to another section or another page. It's not hyperlinked in any way like that. It's just really text in the pager that we're looking at. So that's a couple of different ways to get help. And as I said, you'll find you may get stuck in a lot of cases. You may remember a command, but you don't remember all of the parameters. Just remember that --help put on the command line with a program name may actually get you some help. If it doesn't, you could use man or info and get some additional help for those programs that you're stuck with. I'm back in the command line, and in this lesson we're going to be talking about actually the program that you're really interacting with here. The program you're actually interacting with is something called bash, and bash stands for the born again shell, and it's a bit of a pun. It's born, B-O-U-R-N-E, as opposed to B-O-R-N, and it's really a pun because the original shell for Unix, or one of the original shells, was actually the Bourne shell. And when Linux was created early on, we ended up with Bash, which was the Born Again shell. It took the original Bourne shell and made some enhancements to it. Now, I've got my Born Again shell here, and I can type commands, and it can certainly do things like that. I can also do things like set aliases, and that's really a function of the shell itself. Now, ls is a program, and I can call that program from inside the shell, but there are other things that are really a function of the shell. Interestingly, while the shell is an interactive environment for you, where you can type commands into, it's also a programming language. So let me take a look here. This is one of the startup files that would run when you logged in. And you can see there's really a lot of code here, and you may not understand any of it, or you may understand some of it. But what this is written in Bash, and this is written in Bash as a programming language. It uses the same program that you are interacting with directly, and you can do programmatic things like check to see whether this is running interactively. So it's using a case statement, and we check the value of this particular variable here. So as a programming language, I've actually got a number of variables, and many of these are just built in. So for example, $shell. $shell is a built-in variable that belongs in Bash, and echo just says print that variable out. So if I echo $shell, I'm going to get the contents of that variable. And in this case, it's /bin/bash. Now, I could run a number of other ones. So, for example, PS1 is my prompt. So this is the prompt that I've got here. There are a number of other variables that are built into Bash, and you can certainly look those up and see what else you can print out. But again, we've got this programming language that's built right into this interactive environment. So I can do if statements, for example, and I could do these right on the command line if that's what I wanted to do. I can just start typing things in. I could use for loops, for example. I could do if statements and so on and so forth. So Bash is not only this interactive shell that we're working with, but it has within it some programmatic functionality as well, so you can do things in a more automated fashion, which is really one of the nice things about Unix, is it's really always been designed as a programmer's operating system and something where you can use a lot of different tools to get things done quickly and easily. And Linux just maintains that history and heritage and has the same sensibilities, so Bash gives you some ability through the programmatic functions to do things quickly and easily. Now, I'd be remiss if I didn't show you some of the internet applications. I know we're going to spend some time in the command line, but there is this graphical user interface here as well, and you can certainly make use of this because it's got a lot of functionality, just like, any other graphical interface on other operating systems. One of the things is you can have a web browser. There are a number of web browsers for Linux. Firefox happens to be one of them. You can also use Chrome. There are a number of descendants of Firefox that use the same source code and get compiled in a different way. So there's Iceweasel, for example, which looks and behaves very similar to Firefox. And I can do all of the usual things that I do with Firefox. I can go to Google, I can go to Gmail, and I can check my Google Mail, and it's going to ask me if I want to install an application here, and I'm not going to do that right now. But I do have browsing capabilities. As I said, I could get Firefox, I could get Iceweasel, I could get Chrome. Opera also works for Linux. I can't actually get like Safari, for example, and I can't get Internet Explorer. And actually, Chrome isn't Chrome under Linux, it's Chromium, which is the open source version of Chrome, but it's the same thing, same source code, going to look the same and act more or less the same as you're used to on other operating systems. Now, there are other programs that you may be used to. If you're used to using an instant messaging program, for example, there are instant messaging programs available for Linux. One of them happens to be Pigeon. Pigeon is actually pretty good. It used to be named Game, and it's changed its name. It's called Pigeon. I can go through and I can add accounts for a number of different protocols. You can see probably every protocol you could think of is actually here. There may be a couple that are missing, but for the most part, anything that you can do with an instant messaging account, you can probably do through Pigeon. You may also be used to doing mail outside of your browser and using a more traditional client application for that. Well, there's Thunderbird. There's also other mail programs. Thunderbird happens to be a pretty popular one. It comes just installed automatically. And I'm going to skip this, and I can set up my mail accounts as I choose to using Thunderbird. And Thunderbird, again, is one of those that's across multiple platforms. And I can run Thunderbird on Mac, I can run Thunderbird on Windows, and of course I can run it here on Linux as well. And it looks and behaves the same on all of the platforms, more or less. Different quirks for different operating systems and how the interface interacts with the application, but the core functions are going to behave just as they normally would with the other operating systems. So that's going to work just the same way. So we've got our browser, we've got an instant messaging application, we've got mail. You may have seen there's also a music player here as well. There's the ability to do videos. So lots of your kind of standard graphical programs, and certainly the internet-based ones, are all here under Linux. And if they're not here, you can certainly install them, and we'll get into how you would go about installing those applications a little bit later on. In this lesson, we're going to be talking about how to get listings of files, and we've looked previously at how I would do it on a graphical basis, and we've looked at the File Explorer, and as I said earlier, this is pretty much the same as any other File Explorer you're going to run across. We can go to Home here, and I can see all of the different directories that I've got, and I can click through, same as pretty much any other File Explorer. Now, as I've mentioned previously, one of the real powers of Linux comes with the command line. And I can do something like an ls, and I get pretty much the same thing as I get with the File Explorer that I had. And in this case, the way that I've got the shell set up is so that different types of files or different objects are actually colored differently. So you can see that in this case, my directories are colored blue. If I were to have an executable program, for example, then that would be a different color and so forth. This is just a pretty straightforward listing. I can get a number of different types of listings. If I were to get help, for example, I can see all of the different flags that I can use. And a pretty common one here is I could do an ls-a, and that's really going to give me every file. Suddenly you see there's a number of files that weren't there before. These right here are called dot files. So you can see, for example, .xauthority. That's a dot file, and normally that won't show up in a file listing because it's considered kind of a system file or a system level file, and it's not one that would normally show up in a file listing. And in a place like where we are here with my home directory, then I've actually got a pretty large number of dot files. You can see the number of dot files because those are commonly, for example, configuration files like this one here. The .bashrc is a configuration file. .dmrc, that's also a configuration file. And I've got all of these configuration files that are dot files. Now, you'll see what I don't have here is a listing of creation time, for example, or size. I could do an ls-la, and that's going to give me a long listing in addition to all of them. And now I've got the permissions on the left-hand side here, and that's followed by the owner, which is the third column in, and then the group is the fourth column in. Then we've got the size, and that's followed by the date and time, and then of course the file name. Now I've got my listing of files, and I've got all of the details around them. And as I said, we can do some other things here, like I can do a sort, for example, and I could do human readable. So let's do a human readable listing. So if I did a -lah, instead of the numbers that we had in the fifth column over, I've actually got something that may be a little bit more meaningful. So for example, I've got 4K and I've got 3.6K. Rather than just a raw number, it actually breaks it down. If I had a big file here, you'd see like an M or a G, for example, for meg or gig. So that's human readable, and it translates some of the numbers into things that may make a little bit more sense to us immediately, rather than having to do the translation in our head. So I can get file listings, I can manipulate those file listings in a lot of different ways, and you'll see this probably a lot as we go forward, as I continue to show things, particularly like permissions and the different settings that we can do on the files. I'm certainly going to be doing file listings to show you the results of those. So we'll keep talking about LS and some of the features and functions of doing file listings in the console or in the terminal. In this lesson, we're going to be talking about file permissions. And we took a look at this very briefly in the file listing video, and I'm going to show you a little bit in more detail what all of that means. Now here we've got a set of file permissions that are associated with a particular file. In this case, it's the file dot, which is just the current directory. Dot is the current directory, dot is the directory that's above. Now, let me just create a file here really quickly. I'm just going to use touch, which is going to create a file, and let me just call it Rick. So I can do ls-la Rick, and that's going to give me a file that's got no size at all. It's just a file name, so it's an entry in the file table, and that's all there is to it. You can see here what I've got is a set of permissions, and let me explain what those mean. Now, the first on the left-hand side here, we've got a dash, and that indicates whether it's a directory or whether it's a regular file or whether there's something else particularly special about the object that we're looking at. In this case, it's a dash, which means there's no special bit set or anything like that. Now, permissions under Unix are grouped into We've got owner, we've got group, and we've got world, or everybody. So the first set of permissions that we're going to take a look at is the permissions for the owner. And the owner of this particular file is my user. And you can see an RW. That means a read and a write. Now, they're actually set numerically, so there are actually bits that are set that create these permissions for us. And going from the left, we've got read, which would be a value of 4. Write is a value of 2. And then the final one is an X, which is an execute. So unlike Windows or other operating systems that you may be familiar with, where the executable is handled a little bit differently, under Unix, I can make anything executable just simply by setting the execute flag on it. In this case, I've got no execute flag, so there's just a dash there. And that execute flag would be a value of 1. Now, if you think about it, this is powers of 2. The first position is 2 to the 0. That's the execute, reading right to left. We've got 2 to the 0, which, as I said, of course, is 2. And then we've got 2 to the 1, which is 2, and 2 to the 2, which is 4. Now, if I add all of those up, I get 7. If I wanted to give myself all of the permissions that were available on this particular file, I would use the chmod or chmod command. I could do something like u plus w for the user, and that adds the write flag. What I want to do, though, is I'm going to say 744, which indicates that I want the owner to have read, write, execute, and then I want read for both the group and the world. So I'm going to do chmod 744 rick, and then I do an ls-la rick again, and you see I get read, write, execute, and then RR. And you'll also notice the color of the file name is changed. So executable files become green with the way that we're doing the file listings. So let me remove that execute bit, and I'm going to do chmod, and then let's just do 662 here. And now I'm going to have 6 is 4 plus 2, so that's going to be read plus write. And that's the first two groups, which is the owner and the group. So I'm going to have read write for the owner and the group. And then the final clump of permissions is everybody or world. And that's a 2, which is, of course, a write. So if I do an ls-la, I should see RW, RW, and then W. And sure enough, that's what I get. So I get an RW, an RW, and then a W. And that's the 662. Now, the permissions bits can be challenging to use if you're not kind of familiar with the values for all of them. As I said, executable is 1, write is 2, and read is 4. So you would have to add up those different numbers based on the set of permissions that you want to use. So as I said, we could also do something like u plus x here. And then if I did an LA rick, I should get the executable bit that's set, and sure enough, that's what I do. And u is user. I could also do chmod g plus x, which is going to be the group. And if I do that on the rick file, and then I do an ls-la again, I get the x. And of course, I could do a minus as well. So if I did chmod g minus x rick, and then we'll take the listing again, and the executable bit is gone. So if you're not comfortable with doing the numeric approach, you can also do user group world. And you can do a plus bit or you could do a minus bit, depending on whether you want to add or remove those different permissions. In this lesson, we're going to be talking about file management. Now, again, I could certainly go back to the File Explorer here, and I could just start dragging and dropping things. But let me show you the console way of doing it. It's pretty easy, actually. There's a couple of commands that you're going to want to know. So let's go back to our file that we were playing around with before. Right now I'm in my home directory. I used the pwd, which is print working directory, and it told me I'm in my home directory. Let me actually copy this file, and I'm going to copy it into downloads. You can see that it's still here, and if I did an ls-la downloads, you can see that it's there as well. Same file, and I've got 2 copies of it. One is in my home directory, and one is in the downloads directory. Now let me just remove the one in the downloads directory. RM is for remove, and I'm just going to remove that one. If I wanted to actually move it, I could move it into downloads, and now if I do ls-la, I get no such file or directory. If I do ls-la downloads, now I've got the file there. So I've got my move, I've got my copy, and let me actually rename the file that's there. So I'm going to change directory into the downloads directory, and I'm going to move Rick into my file. Now I've renamed the file. It no longer is Rick, it's now my file, and I can actually move it, and if I do a ... it's going to move it up a directory. So you can see it's gone now, and I'm going to jump up 1 directory level, so I'm not in downloads anymore, and you can see my prompt has actually changed. It no longer says downloads, it now just says wiggle, and wiggle is, in Unix or Linux terminology, wiggle just means home. So I'm in my home directory, and I can just show you that. And if I do an ls-la on my file, because of course that's what it's called now, you can see that my file is now back in home. So I've got cp, and I've got move, and move not only moves things, but it renames them as well, because you're moving it to a different file name, if you think about it that way. And I've also got, we also looked at RM. If I wanted to remove my file, I could remove my file, and then it would be gone. Now, when I'm at the command line, removing deletes it. Doesn't go to a recycle bin, so you can bring it back later. It flat out deletes it. So if I wanted to make sure before I deleted something, I could do rm-i. So let's see what I've got here. So I could do rm-i examples.desktop, and I showed you this earlier with an alias. If I did rm-i, it says, do you really want to remove this? So it's going to prompt us to make sure that we actually want to remove it before we go delete it, because deleting it like that is permanent. Can't get it back from going to a trash bin or a recycle bin or anything like that. It's just gone. In this lesson, we're going to take a look at the file system layout, and I'm going to do it in a couple of different ways. So the first thing I want to do is I'm going to do ls/. Slash is the root of the whole file system. Under Linux, there's not letters for drives, there's not names for volumes. There's just one file system, and it all belongs under slash, which is root. Everything belongs under root. There's no other place to put things somewhere else. This is the whole universe when it comes to files on your Linux system. So if I do ls/, I'm going to get the root of the file system. And you can see I've got some directories, and let me just pop open the browser as well here. So if I go to computer, it's actually bringing up the root of the file system. Just in case it's easier to see the folders here, as opposed to translating the darker blue in your head to folders versus the other ones, which are actually links to other locations. We've got bin, which is short for binary, and that means that's where programs live. Etc is where all of the configuration files for the different system programs and utilities is. And that's this right here, that's etc, and it's generally pronounced etc. I've got the boot directory here, and again, we've got it up here. So I'm just showing you the folders here, and you can, of course, follow along with the listing in the console as well. It's the same listing. Boot is where all of the boot files live. So that's actually where the operating system itself is in the boot directory. That's the kernel, which is the operating system. And that's all of the boot files, including the configuration file. CD-ROM is what we call a mount point. If I actually were to put a CD in, it would mount to this location in the file system. So it would just join the file system into this folder right here. We've got dev, which is where all of the devices are. Under Linux, every device gets its own file. It looks like a file when I interact with it through a file explorer. It's really more of a pseudo file because it doesn't really exist as a file within the file system. It's a pseudo file that the operating system puts there so you can directly interact with devices. We've talked about etc home is where all of the home directories for the different users are. You can see there's only one user on this system, and that's my user, so there's only one directory in the home directory. We've got lib, which are libraries. Those are different sets of code that may get pulled in by programs. So if you think about Windows and DLLs, Linux doesn't use DLLs, but they do use something similar, and lib is where all of those files live. We've got lib64, which is where the 64-bit libraries are. Media is if I were to put a USB stick, for example, in, it might get mounted under the media directory. At the moment, we've got anything that I might mount would get mounted under my directory here, and PSF is for the parallels, so it can actually get to my host operating system files. Then we've got mount, which is another place where you might mount removable media, for example. Or you might just mount anything that you had through another drive-in or whatever. You might want to mount it into mount. Opt is for optional software. And right now I don't have anything installed, but there's some software that actually goes there, programs. Proc is for processor-related data. Again, this is a pseudo entry in the file system. It doesn't really exist. Every process gets its own directory here. So we've got process 2, and there's all of the data that's associated with process ID number 2. And we'll take a look at the proc file system a little bit later on. Root is root's home directory, and run is where some temporary data gets stored. And then we've got sbin, which is for system binaries or system programs. We've got srv. There's currently nothing there. If you had some particular types of servers would store data in that directory. Sys is for system data. Again, that's another pseudo file system. Temp is where swap files are stored, and it's actually just a temporary directory. If you had something that was just temporary you wanted to put in there, you could do that. USR or user is where user-related data is stored. We've got binary. We've got lib, we've got include, source, share, and sbin, which again is system binaries. So this is user accessible binaries. So bin and sbin are things that are more system oriented, where user is more user oriented. So this is where you'd put user related programs. Var is any variable data. One of the things that's really important that's in here is logs. Unix and, of course, Linux has pretty extensive logging. If you ever run into a problem, you're going to want to look into the log directory, and that's stored in var. It's stored there because it's variable length. It changes a lot, and so we would put that in the var directory. So this is where different things are located. And across Linux and Unix, there's really a core of directories that are going to pretty much stay the same. And mostly there's a couple that may be different. Media and mount, for example, may be a little bit different. Run may be stored somewhere else. But for the most part, you're going to see bin and etc and home and opt and user and var and temp. So you're going to see those directories no matter what the Linux distribution or matter what the flavor of Unix that you're working with. These are pretty consistent, and you're going to see these no matter where you go. In this lesson, we're going to talk about another environment variable. And this is an environment variable that's actually pretty common across operating systems. It exists under Windows, although you don't see it a lot, but it's there anyway, and it's one of the environment variables. It's the path variable. Now, the path variable is a variable that indicates where the system should look for programs or executables. If I were to do an echo $path, it's going to show me that this is my path here. So if my system needs to look for a program that might exist somewhere on the system, then it's going to look in one of these directories. And you can see the directories are actually separated by colons. So there's a colon right here, and all of the others are directories where programs might actually exist. Now, there's a couple of things that are actually missing from this, and one of them I could actually add here. So I'm going to export path equals $path, because I actually want to use the existing path, and then I'm going to put a colon here. And now I'm going to add my home directory, and then let's say I've got a binary directory or a bin directory inside my home directory. I don't happen to, but if I did, and that's where I wanted to keep some of my own programs, and I wanted to be able to get to them no matter where I was, then I could add that to the path. Now if I do echo $path, I get that. I could just start over, and I could say path equals, let's say user local games, and then home and my bin directory. Now, there's a number of utilities and programs that aren't going to work any longer. ls happens to be one of them because it's located in bin. So let me just add that back in. And export isn't a program. Export is a built-in function of the shell. So no matter what I do to the path, export's always going to work. So I'm going to say export path equals, let's add in bin, and then user local games, and then my home directory. Now I can do ls again because I added the path back in, and the system was able to find the binary. Now, the shell was very helpful here. It says ls is available in /bin/ls, but it couldn't be located even though it knows where it is because bin is not in the path. Now, what I could do, let me export the path again to, let's just say it's wiggle/bin, so just my directory. So if I go into /bin, and cd again is one of those built-in functions of the shell, as opposed to an executable itself. Now what I could do is do, and I did that really quickly, and it changed really quickly, /. So I'm telling the system where it's actually located, and that's in dot, which is the current directory, and /. Or I could just go back to my home directory, and I could do, and I can't clear it because of course that's in the path. What I could do though is I could specify exactly where it is. Now I'm bypassing the path altogether, and I'm telling the system this is actually where you go find this program. So it's in user bin, and you'll notice I don't say the slashes because that's pretty common shorthand. If I say user bin, people who are familiar with Linux know that it's /user/bin, and I just say user bin so I don't have to say the slashes. It's just a shorthand. If I do that, if I say /user/bin/clear, then I run that program, of course it's going to execute. So I'm home now. I could do /bin/ls, and ls is going to work. That's the path variable, and I could actually get it back now because it runs every time I log in. So once I do the terminal again, and I do echo path, and this is where the configuration files that we were looking at several lessons back for setting a number of parameters for my bash session, this gets set in there. So every time I open up a terminal session, it's going to run that configuration script, and it's going to set my path for me. And so I've got echo $path there, and it shows me that my path has been restored, even though I did a pretty good job of mangling it up. In this lesson, we're going to be talking about file editing. There are a number of ways of doing file edits, and one of them is just doing a redirect. And I'll talk about redirects in more detail later, but what I can do here is I could say echo this is my file, and I'm going to dump it out into a file called my file. So I've got my file, and I'm going to use a program called cat here to actually take a look at my file. And cat is short for concatenate, and that's really what it does, is it concatenates files. If I don't give it any other file, it's going to concatenate my file with nothing and just print it out to the console. I could do concatenate my file with my file. It would print it out twice. And of course, I could redirect that into another file and get both of those. That's how cat works. I give it as many files as I want, and it just concatenates them and spits them out to the screen. Let me actually take a look at editing some files here, though. Nano is a file editor that's pretty popular on Linux. It's a pretty easy editor to use. I can just use my arrow key and move around. I can use backspace. I can insert things. And when I'm done, I can do first a Control O, which you can see on the bottom of the screen here. I've got Control O for write out. And then I want to exit. And in this case, I don't actually want to write it out. I just want to exit, which is Control X, as you can see on the bottom of the terminal here. It's going to ask me if I want to save it. I'm going to say no, and we're just going to leave. Now, for people who have been using Unix or Linux for a while, VI is a more popular editor. Part of that is because it's been around a lot longer. It's a very different editor than most other editors you're going to use. I'm actually typing characters onto my keyboard here, and you'll see that nothing is actually changing in spite of the fact that I'm typing. VI is what we call a dual mode editor. Now, I can do a lot of things right now, even though I'm not in edit mode. And if I want to go into edit mode, I can type some characters like capital A puts me into append mode at the end of the line. So this is the end of the line. And if I want to get out of edit mode, I just type escape. If I want to insert something here, I type I, and I'm in insert mode, and I can just start typing characters. So that's how you would just do some basic things in VI. VI is a far more complicated editor to use than something like Nano, and it does take a lot of getting used to VI and how it operates. It is, as I said, a pretty popular editor, and that's certainly another way that you can edit files in Linux. In this lesson, we're going to talk about some of the pseudo file systems that I had mentioned previously. The first one I want to take a look at is the dev file system. The dev file system is where all of the devices that are in the system are stored, and that doesn't mean that they're physically stored there. This is where the kernel, or the operating system itself, actually places entries inside /dev so that we can directly access these devices. I've got hard drives, or I guess I've got one hard drive in this system, and you can see the device actually down here. It's SDA. So I've got SDA, and that's actually the device name of the hard drive that's in my system. If I wanted to do something with the hard drive, I could go to this device entry in the device tree and actually like mount a partition, for example, or I might be able to look directly into the data that's on the file system itself or on the device itself. You can see I've also got other entries. I've got CD-ROM, for example. I've got CPU. I've got disk directory. There's a lot of different devices here, and they all relate to different components within the system. And again, if I want to get access to the device itself, I would go through this device tree. That's just how Unix and Linux work, is you go through this device entry in order to get access to the hardware. Now, another entry that's a pseudo file system that's in our overall file system is actually the proc file system. The proc file system, as you can see, has a lot of numbers in it. What these numbers correspond to is actually process IDs of running processes. The very first process that ever starts on a Unix or Linux system is called init, and that process, not surprisingly, has a number 1. And you can see in the top left corner here, I've actually got an entry for 1. So if I go into proc/1 and I take a look at what's there, I've got a number of files as well as some directories. I've got, for example, the command line, and I could take a look at the command line that was used to actually launch the program. You can see that the command line that was used, or the command that was used, is sbin init. I can also take a look at some memory statistics. I can check the status, look at system calls, and also take a look at the memory that has been allocated to this particular program. And in some cases, I may actually be able to look at what's actually in that memory. I can also take a look at anything related to the network, and I can do all of that just from this directory. Now, again, these aren't real files. These are just things that are populated to look like files, and they're populated by the kernel or the operating system so that I can get direct access to information about running processes on the system. The last pseudo file system I want to look at is the sys file system. The sys file system, or the sys directory, is actually where I can get to a lot of the settings that exist within the kernel or the operating system. I can go into, for example, let me take a look at kernel here, and I can see some information here. Let's take a look at the kexec crash loaded. So I've got a binary number here, and this is a 0, so that indicates that the kexec crash loaded flag is set to false. So I can take a look up here, and I could go into devices, for example, and then from there I can go into system, and I can keep digging down through here, but bottom line is there are a lot of entries in here that give me the ability to actually set particular flags for the operating system so I can change the behavior. Now, while I can go to this directory directly, I can also make changes to it using a program called sysctl. And we'll get into looking at how sysctl actually works and the things I can do with it a little bit later on. But I did want to introduce, as we're looking at the sys directory, that there is a program that I can use to actually make changes to these system control variables, so I don't have to go digging through all of these directories looking for a particular file or a particular entry that I want to make a change to. Now, those are the 3 pseudo file systems that exist on a Linux system, and as I've mentioned previously, these exist on all Linux systems regardless of the distribution. These are all basically resident within the kernel itself, which is, of course, what Linux actually is. Linux is the operating system, it's the kernel, and all of the rest of it is programs and utilities. So any Linux distribution is going to have all of these directories because it's actually Linux, the kernel, that is providing them to us. In this lesson, we're going to be talking about file sharing. Now, I can share files with a Linux system over a network that primarily has Windows systems on it. Linux can talk the same protocols that Windows uses in order to share files. Now, the package that you would use to do that file sharing is called Samba. And as with most Linux packages, if you want to do some configuration work, it's really just a simple text file. So I'm looking at the configuration file for Samba, and I can set the work group here, I can set server string, I can set up wins service. I can also go down, if I keep scrolling down, there's some sample configurations for how you would go about setting up sharing. So for example here, we've got homes, and I'm just going to uncomment these. It's going to give me the ability to share just the home directory for each user. When I want to get access to that, I would use // server, so the name of this system here that I'm working on, and then my username, and that's how I'd get access to the home directory. I don't want it to be read-only. I'm going to leave the create mask and directory mask alone, and that all looks okay. So I could now save this, and I could restart the Samba service or SMB service. And now I would be able to gain access to the home directories on this system. Now I could also use SMB client, which would allow me to get access to shared directories on other systems. So if I use SMB client, I can connect to another system on my network that's using the SMB protocols and Windows sharing, and I could get access to the files that way. So Linux does have the ability to do file sharing with Windows systems. You would use Samba if you wanted to share your files, and you could use something like SMB client, or the File Explorer would give you the ability to connect to remote systems that were doing Windows file sharing as well. So you can see I've got a Browse Network button here, and we can see a number of systems on my network that are doing file sharing over a Windows network. So that's how you would do file sharing with Linux. In this lesson, we're going to take a look at how we can find files on the system that we actually need to locate. The first thing I want to show you is a command called which. Which actually looks for executables or programs. So I could do which, for example. I can do which ls. I could do which Perl, for example. I could do which Ruby. And in this case, I don't actually have a Ruby installed. Ruby is a programming language. I don't actually have the interpreter installed for that programming language, so I get no response back there. But I can do which, and it will actually tell me exactly where that is located. And which works by looking through your path to be able to tell you exactly where the program is stored. So there are locations that which knows to look into to be able to find those answers. Now, sometimes you may not be looking for a program, you may just be looking for a file. And in this case, I'm going to bump my privileges up, and I'll get into talking about how the program Pseudo works a little bit later on. But what I'm really doing here is I'm escalating my privileges to a higher level so that I can look into directories that I wouldn't otherwise have access to as my own user. If I use find, I need to tell it where it's going to look, and so I'm going to tell it to start in the root of the file system. Now I need to tell it a name, and I'm going to say logs, and then I'm going to just say print once it's found it. Now it's going to go looking through the file system, and anytime it runs across a file with the name logs, it's going to print it out. And this can take some time. Actually, we didn't turn up anything. Let me change this a little bit just to show you that I can use wildcard patterns here as well. So now what I'm looking for, and I actually have to put it in quotes so that this isn't taken as something literal. So what I'm saying here is anything that starts with whatever and includes log and then ends with whatever, that's a file name that I want to look at. You can see here that we've actually got a lot of them. There are a number of files that include just the three letters log in it. So I've got login.conf, and I've got syslog.service, and I've got a lot of files that actually match that pattern. Now I could do something like, let's say in my own directory, I want to find the name desktop, and then I'm going to print that out. So in order to look in my own directory where I am right now, I'm going to use the location dot, which just says this current directory. And so I'm going to look in the current directory for a name desktop. And of course, because that's actually there, it's turning that up. So what I could also do, and again, we're going to get into some of these things a little bit more. And again, this is really the power of Linux. If I were to do something like this, and what this says is, doesn't matter how it starts, as long as it has desktop with either a lowercase d or an uppercase d, and that's what these brackets say, is this letter here before ESKTOP can be either a lowercase d or an uppercase d, either would work. And the asterisk again says anything before it is fine. Now we've got examples.desktop, and then we've got some things under XFCE that have desktop in them. And of course, we've got the desktop with a capital D that we had previously. So find actually has a lot of capabilities if you know how to manipulate the different ways of looking for things like the brackets and the asterisks and those sorts of things. And we'll get into some of that a little bit later on, where we can do some more advanced pattern matching. But find and which are two really useful utilities if you are looking for things, whether they're programs or whether they're just a file that you know is somewhere on the system, but you're not really sure where it is. In this lesson, we're going to talk about redirection. Now, I covered redirection very briefly earlier on, and I want to explain it in a little more detail so you can understand what's really going on. Redirection is when I take the output of one program and send it to a file. Now, I'm just going to do a really simple demonstration here. So I'm going to take ls and I'm going to redirect the output of ls and I'm going to send it to a file called ls.txt. You'll see I don't actually get any output here, and that's because I have sent stdout, which is the standard output, into the file ls.txt. I've redirected it, so I don't get anything on my console here in my terminal window. It's all gone out to the file. So if I just cat ls.txt, I get the files that would show up in my file listing. I can also do an append. If I just do a single greater than, what I get is either a creation of a file if the file doesn't exist, or if the file does exist, it's going to overwrite the file. If I don't want to overwrite it, I want to append to it, I could do the greater than greater than. Now if I do cat ls.txt, now I get both file listings here that are back to back because I did the appending to the file rather than creating the file. I can also do things with error output. With Unix or Linux, I actually get 3 input-output streams just by default. I get standard input, which is stdin, I get standard output, which is stdout, and then I get standard error, which is stderr. I could take the output from a command that was going to be generating a lot of errors, and I could send that off to somewhere so I didn't actually have to see it. So let me give you an example here. If I do a find and I start in the root of the file system and I say I'm looking for name, password, and then print, I get a lot of errors that say permission denied. And I'd rather not see those, I'd rather just see the output. So what I can do here is I can say to greater than, which says stderr should go to this file that I'm going to say. 2 is actually the numeric value for stderr. And I'm going to say redirect stderr to, let's say, errors.txt. Now all of the errors are going to go out to the text file, and eventually it's going to print just the file that has the password in it. So you can see now I'm just getting the output from this find. And the reason I got all of the permission denied errors is because I wasn't running as a root or super user who has the permission to access those files and directories. I'm running just as a standard user. Now what I can do is I can cat out the errors, and you can see all of the errors that I got where I got the permission denied because I'm just a normal user. So lots of really useful things you can do with redirection between stdin and stderr and stdout. You can do redirects, and we actually didn't talk about redirecting stdin. I could actually do a redirection with the less than symbol, and that's a little bit more complicated, and we're not going to show you that right now. We may cover that briefly later on if there are some specific examples. That's not one that you would commonly use just kind of tooling around on your Linux system. Doing a redirect of your output and a redirect of your standard error, though, those are pretty common, and you may find a lot of use for doing those things. In this lesson, we're going to be talking about special files. There are a small number of special files that exist within Linux for special purposes, and sometimes it can be really useful. Now, you remember previously when I was doing the redirect and I did a find for password files, and I got a lot of errors, and I redirected the error output to a file. What I can also do is the same thing here, but I can redirect the error output to a special file that's called dev_null. And dev_null is really just a data sink. Anything I send to it is just going to disappear. I'm never going to see it again. So it acts like a file, but it's really a device that you can just send things to and never have to worry about seeing them. If you're running a program or doing some operation that's going to generate a lot of errors, and you know it's going to generate a lot of errors, but you don't want to see the errors, you just want to see the clean output, you can send the error output to dev_null. Now, I can also send the standard output to dev_null, and I get the same effect. I don't get any files. I don't get any output to the screen or console. I get nothing. Dev_null is just consuming everything that we send to it. Now, I can do the same thing with another device called dev_0, and that works similarly to dev_null. What I could also do with dev_0, though, is I could, for example, I'm going to use a disk dump command, and I'm going to say dev_0, and my output file, let's say, is going to be 0.txt, and I'm going to say count equals, say, 250. Now, if I just cat 0.txt, I get a lot of zeros, and I don't get anything printed because what I'm getting is the 0 character or the null character, and so I'm not actually seeing any output because it's not the ASCII 0 like this. What I could do would be to, let's look at it this way. You see all of the zeros, right? These are the 0 value as opposed to the 0 character. And I used a little hex dump here to show you that there are actually zeros there. And if I do the 0.txt, I can show you the file size. It's 128K, so I've got basically a big file of a lot of zeros in it. But the zeros aren't going to output because it's actually the null character. Now, what I can also do is say, let's take a look at urandom, and that's a random number generator. So I just did a cat on /dev/urandom, and that just started generating a lot of random numbers for me. And you can see that what I've got is a lot of non-printable characters because it's generating numbers that my screen is actually trying to print out as characters when what they really are is numbers, and that has to get converted to an ASCII value or an ASCII character from that numeric value so that it can print to the screen. So you probably don't want to just dump urandom out to the screen. You may want to dump it into a file and then maybe try to read the numbers out of that file. Or you could use it in a program to generate random numbers for you. So that's a couple of special files that you may find useful. We had dev_null, dev_0, and dev_urandom. In this lesson, I'm going to talk a little bit more about dot files. And I had previously mentioned dot files really quickly. And again, if I do an ls-la and I scroll to the top, I've got two dot files. I've got dot and I've got dot dot. Dot is the local or current directory. So it's where I am right now. If I do an ls of dot, I'm going to get everything in my current directory. Dot dot is the directory above. So if I do an ls on dot dot, I'm going to get the listing of the directory that's above where I currently am. Now, there are some useful reasons for doing something like this. So let's, for example, I'm going to copy to my local directory, and I'm going to call it ls1. Now, I can't just run ls1 because dot isn't in my path, and it doesn't just assume that that's where it is. If I wanted to run it out of my local directory, I would do dot slash, so that says use the current directory, and then run ls1. Now, if I were to drop into desktop, and I wanted to run ls1, I would do something like this. I would do dot dot slash ls1. And there's actually nothing in desktop, so let's actually do this instead. Dot dot slash ls minus la, and then I at least get the dot and the dot dot there. I can go directly to things like programs using dot and dot dot if I happen to know they're near me and they're not in my path. I could also do, let me go back up a level. So cd dot dot brings me up a level into my home directory. So I could do something like this. Dot dot slash dot dot should bring me up to the root, and then I can say etc password. And once I'm in the root, I can get to slash etc. And I did it just by jumping up 2 levels here by saying dot dot slash dot dot. And I could do that no matter how many levels deep I was. I could say dot dot slash dot dot slash dot dot, and that's just going to keep hopping me up a level in my file system or my directory tree. I can do dot and dot dot to reference specific files or to get more immediate access to things. Like if I'm really deep in a directory listing, I don't want to do, say, slash home slash my username slash package slash source slash my source slash whatever. If I were somewhere in that directory listing, what I may want to do is just something like dot dot slash and then my file, for example. So it's an easier way to move around the file system is knowing these dot and dot dot methods of getting access to things, so you can more quickly and easily make reference to files or programs rather than using full path names. In this lesson, we're going to be talking about links. There's a couple of kinds of links that you would use in a Linux or Unix operating system. And first of all, we've got a hard link, and then we've got a symbolic link. And there's a difference between them, and it's actually a pretty significant difference. If I wanted to do a symbolic link, I'm going to use ln, which is the tool that's going to create the link for us. If I want to create a symbolic link, it's really like creating a shortcut. I could do, for example, create a link to etc password and just put that right here. Now, when I take a look at the password here, you can see that it's actually a link. I've got password, and it tells me here that it points to etc password. If I remove password, all I've done is remove the link. I don't actually have it here, but I do have etc password. A symbolic link refers to a particular file name. Now, a hard link uses the same tool, but I don't do -s. I could do etc password and call it password here as well. And actually, let me do this a different way. That's going to be a privileged file, so I'm not going to be able to do it inside my directory. So let me do this instead. Let me create a link to ls.txt, and let me call this lslink.txt. Now I've got lslink.txt, and let's take a look at what else we can find out about it. You can see here that I've got lslink.txt. It looks like a regular file. In fact, that's what it is. It's a file that points to the same place on the disk as ls.txt. So I've got basically 2 file names that point to the same location. I can actually remove lslink.txt, and I'm going to remove that link to that data file. And actually, if you take a really close look here, you'll see before I had a 2, and that indicates the number of references to that particular set of data on the disk. Once I remove the link, I've got a 1 here, and that indicates I'm now down to 1 reference to that location on disk. A hard link points to the place on the disk where the actual data is stored. A symbolic link just refers to a file name, regardless of where the data actually is. If I remove the file name, so let's do another symbolic link here. If I were to ln-s ls.txt, so that's my source, and I'm going to say lslink.txt here, and if I do ls-la lslink.txt, I've got my link there. So now let me get rid of ls.txt, and I've still got my link, but it should turn red at this point, and that indicates that it's a broken link that doesn't actually refer to an existing location. You can see down here that we've got a red entry in our directory listing because it means that it's broken. Now, I can use links for a lot of different purposes. For example, what I may want to do, let's say I'm doing a lot of web development, and I want to more quickly and easily get into the web directory that I'm working in. So I may want to do /var/www, and I'm going to give it a link of web, for example. Now I've got web, and actually that's broken, presumably because var www doesn't exist. Right. So I created a symbolic link to something that doesn't exist. If I were to create that, now let me take a look at web, and now we've got an indication that it actually points to a place that exists. So now my file name that I was pointing to exists, and so the link is active. So lots of different purposes for using links. As I said, if I were to do a lot of web development, maybe I wanted a local directory to jump into rather than typing cd/var/www. I could just do cd web, and then I'd be in the same place. If I do a print working directory, it thinks I'm actually there when where I really am is in var www. So links are really useful. They look like real things when in fact they're actually pointing to some other place. For symbolic links anyway, a hard link is real, just as real as the original file. It points to the data on the disk, and it's just another reference to that data location on your hard drive. At some point you may actually want to compress some files. So let's talk about how to do some compression here. What I want to do is I'm going to zip into myfile.zip, and I'm going to add myfile*. So anything that starts with myfile, I'm going to add to the zip. And you can see I'm adding myfile, myfile2, myfile3, and I've got myfile.zip now. If I want to unzip it, let me actually go into my downloads directory, just so I'm not unzipping over the top of the files that are already there, so you can see clearly that these files have actually been unzipped. So I'm going to unzip, and again I'm going to use the ... notation to go to the zip file that's actually in the directory above where I am right now, and I'm going to unzip those. So I'm unzipping in my current directory, and I've got those files, and I've unzipped them from the zip file. The zip file still exists. And again, I'm going to use the ... notation. You can see it actually is still there, and I've unzipped the files. And I can go back up here, and I can still see that my file is still there. I've got all of them, including the zip file. Now, let me get rid of the zip file here. And I'm going to show you another way of compressing. tar stands for tape archive, and we've used tar for ages now. Even though it's called tape archive, what we're really doing is we're bundling up a lot of files together into one coherent file, and I can actually include compression along with it. When I'm using tar, if I want to create a tar file, I'm going to do create. I'm going to indicate that what I'm going to specify is a file name as opposed to writing out to a tape or writing out to something else. Now, I could just leave it here, and I could give it, let's say, mytar.tar. And then I could say myfile*, and it's going to tar up everything. What I want to do is add compression. And so I'm going to say z for zip, and now I can say mytar.tar.gz, and gz is another form of compression. It stands for gzip or GNU-zip, and that's the way that we compress. We use gzip to actually compress the tar file once we've created it. And actually, let me add another parameter in here, and I'm going to say v for verbose, so you can actually see what it's doing. So mytar.tar.gz, and then I'm going to say myfile*. You can see that it's added myfile, myfile2, and myfile3. If I do ls-la mytar, and we've got the tar file. Now let me go back into downloads and let me get rid of the files that are here. Now I can tar. Again, I'm going to use tar. I'm going to use X for extract, and then F saying I'm going to use a file name as opposed to a device name. And then I'm going to do Z because I've got a zip file, and let me add the V back in here for verbose. If I didn't put the V in, it wouldn't really give me any output. It would just go do it. But I want you to see what's going on. Again, I'm going to use the ... notation to go to the directory above. And then I'm going to say mytar.tar.gz. And again, I've got my files back. If I look up here, I've got my tar. And sure enough, that exists in the directory above. I haven't actually impacted that in any way. I've just untarred the contents into the downloads directory. And let me get rid of all of those again, just so I'm cleaning up after myself, because I don't actually need them there. Now, I've still got mytar.tar.gz, and I've still got all of the my files there. So I've got my tar file, and I've got the original source files. I've just created an archive that's zipped. And as I said, I can do a zip file as well, just using zip. I could also do gzip, and that would do the same thing as zip. So there's several different ways actually to do compression under Linux. So we've got zip, we've got gzip, there's actually bzip too, which you may run across. Any of the popular zip formats will have some sort of Linux analog. You can install a package and do rar, and you can do, as I said, bzip, and you can do gzip. So all of the popular zip formats you can certainly do here. And tar also supports it, and it's a pretty convenient way of bundling up a lot of things into a single file is doing a tar. And you can ship it off to somebody or save it or share it or whatever you want to do. I've been talking a lot about getting packages. And so in this lesson, I want to talk, or start talking anyway, about getting packages for other software that may not be on your system. One of the great things about current Linux distributions is there are online repositories for different software distributions or software packages. And it makes it really convenient and easy to actually install software. Right now I'm in Etsy apt, and if you remember, Etsy is where we store configuration files and various things relating to configuration. I'm going to take a look at the sources.list, which is the list of anywhere I can get software. You can see here, of course, the pound sign or the hash sign here indicates that it's commented out, so we're not using this, but you can see that this is a CD-ROM source. And so if I had the CD-ROM and I wanted to just plug it in here and have it, I could use the CD-ROM as a source. These are more up-to-date, though. These are always going to have the latest version. So I've got deb indicating that it's a Debian repository. And we haven't really talked about where Ubuntu comes from. Ubuntu actually inherits a lot of what it does from another Linux distribution called Debian. And Debian is really a concatenation of the names Deb or Deborah and Ian. Ian is the name of the guy who created the Debian repository, or the Debian distribution rather. And Deb or Deborah was his girlfriend at the time. This is in the early 90s. And so we've got Debian. It's been around for a long time, about 20 years or so now. And Ubuntu and actually several other distributions kind of take their structure and their package management and a lot of the other things from Debian, and then create something a little bit newer and different from what Debian is. I'm still using a Debian-based repository, though, and you can see we've got a website here where we've got some packages with Ubuntu software on them. Saucy is actually the short name for Saucy Salamander, which is the longer name for the 13.10 release. So I've got some software here. I've got some more software which has bug fix updates, and this is unsupported software now, and I'm just kind of scrolling down through. And you can see the comments indicating what each set of repository is all about. And basically, we're going to use software from any one of these repositories. Actually, right here, I've got partner repositories, and let me do this first because I'm not an administrator at the moment, so let me page back down, and I'm actually going to uncomment these, and then I'm going to save the file. And again, I'm using VI for that. I've been using it for so many years, it's kind of second nature. I just do VI because it's quick, and I know how to make use of it. And right now, I'm going to do apt-get update. And update is going to refresh the list of packages that I've got available, and it's actually going to pull in the list of packages from the repositories that I just added. So I've just added several packages that I can install software from. Now, since I updated it, of course, I've got a software updater that automatically runs with Ubuntu, and you can see that since I just did an update and it noticed there was a bunch of things that were out of date, it's asking me if I want to update that. I'm actually going to say remind me later, and we'll talk about how to do an update in a little bit. In this lesson, we're going to talk about installing software and updating software. And I did a lot of stuff with the command line for showing you where the sources were and how to get the latest updates. And let me show you the Ubuntu Software Center. If I click on this here, it's going to launch the Software Center. And this is really just a GUI version of the tools that I was showing you. So I can look at installed software, I can look at the history here, and I can install software directly from this Software Center. I'm going to go back to the command line, though, and show you, just because the GUI is pretty easy to sort through and figure out. But again, the command line has a lot of power and flexibility, and it's kind of where I'm comfortable using. Not that I'm uncomfortable using the GUI, I just tend to find myself in the command line a lot. And so I talked about doing an update, and we pulled in a bunch of packages. We did the update already. If I wanted to get the latest software that's out there, I'm going to do an upgrade. Sudo apt-get upgrade. It's going to tell me all of the packages that are out of date and need to be updated. And I'm going to say, yes, go ahead, continue. And it's going to go download everything and then do the install for it. And it's going to do that automatically. And part of that process actually is figuring out what there are for dependencies. And this is a place where Debian and Ubuntu actually have a lot over some of their competitive distributions, where some of the distributions didn't used to do dependencies very well. You had to figure out what the dependencies were on your own. If you wanted a piece of software and it depended on another piece of software, you would get the piece of software you wanted, and then you would try to install it, and it might actually tell you, no, I actually rely on this other piece of software. And so you'd have to go get that and then figure out what the dependencies were there. The apt system actually will figure out all of the dependencies for you and make sure that you've got all of the software that you need in order to run the one package or the one piece of software that you actually were looking for. In this case, we're doing an update to the software, and again, I would use apt-get upgrade. And most of what I'm going to do in terms of package management and manipulation, I'm going to use the command apt-get. And it can be a little confusing because there's already a verb in there, which is get. And I know I find myself saying apt-get and then package name because kind of in the back of my head, I'm saying I want to go get this package and it says apt-get. And sometimes I forget the verb. So let me show you the search first. Apt-cache. Then I can do search. And this is another editor. And so I'm going to say Emacs. And I can scroll up here. And you see there's a lot of programs that refer to Emacs in some way or another. And this actually isn't anything that I want. All of what I want is going to be right in that section there. So let me actually install that. Remember, if you want to search, you're going to do apt-cache and search. Or if you were using the Software Center, there's just a search box. Let me bring the Software Center back up just so we've got something to compare with. So we've got the search box here. And let me actually search Emacs and see what we turn up. So we've got, under all software, we've got all of these possibilities. If I click on it, I can do install. I can also just do Again, go back here. I'm going to use sudo because I need to be an administrator. Apt-get install. That's the actual verb that I'm going to use, or the method that I'm going to use here. And I'm going to say apt-get install Emacs. And it's going to go out and install Emacs for me. And it turns out that we're going to do 11 new installs, and that's what it's going to do as it goes out and installs stuff. And actually, let me close this. So I'm going to install Emacs, and then let me show you how to remove it in a second here. So I'm going to say sudo apt-get remove Emacs. Okay, that's the question it was asking before, and that's a Y. So now it's removed Emacs. The one thing it didn't do here was remove all of the other packages that it installed when I installed Emacs. The only thing that it removed was Emacs. And that's because it doesn't remember every package that it installs along with one package, because I could actually chain things together here. So I could do apt-get install Emacs and VI and postfix and a number of others. And it's going to go install all of the packages that I asked for. So if it keeps track of everything that it installs with everything else, then you may end up removing packages you don't really mean to remove. So when I remove something, the only thing I'm going to remove is the one package that I'm actually saying remove. Now I can also do auto remove, and that's going to go find a number of packages that are no longer being used in some way, and it's going to go automatically remove them for me. And in this case, it made note of the fact that I don't have Emacs anymore. These are all things that require Emacs in order to really function. And so it's going to go remove them for me, and that's actually what we did. So apt-get is going to do your install, your remove. Apt-cache is going to be able to do search for you. You can certainly use the Ubuntu Software Center if that's what you're more comfortable using. But I wanted to show you apt and the apt system and the apt programs and utilities, just so you could see some of the differences. In this lesson, we're going to be talking about logging. Logging is really a pretty important feature of Linux or Unix systems. Frankly, it's a pretty important feature of most systems, but if you want to really figure out what's going on with applications or do any sort of troubleshooting, you really want to know more about the logging system on your Linux system. Now, traditionally, the logger has been called syslog for system logging or system logger. And there have been different versions of syslog written. Now, syslog is not only a program, but it's also a protocol as well. And as I said, there have been different implementations written of it. And on Linux systems, or Ubuntu particularly, the implementation is actually rsyslog. And let's just take a look at the configuration. Actually, I'm going to bop back up here, and I'm going to take a look at the configuration file for rsyslog. Now, this has a lot of features that are very specific to this particular implementation, and we've got some lines that are actually commented out here that give the ability for this system to actually listen to other systems sending syslog messages. So with syslog, you can actually stick a system on your network and have everybody log to it, so you've got one place to look for log files. Now, I've got some configuration directives here about who owns the files and where they're actually located, and I can go into the rsyslog directory, and we can take a look at the configuration files there. And here we've got a pretty standard configuration. Now, with syslog, you get facilities and you get levels. So I've got the auth and the auth-priv facility, and that tells me that that facility is actually being logged to var log auth.log. And then underneath that, I've got auth and auth-priv, and that goes to syslog, cron, daemon, kern, LPR, mail, user, and so forth. For different levels or criticalities, I can set different types of logging based on the facility. Now, you'll notice that in the configuration file, it actually said things were being logged to var log. So Let's take a look at var log. In var log, we've got a number of log files here. One of the log files is the kern.log, or where the kernel logs its messages. So we can take a look at the kernel.log or kern.log, and this is a log message, or this is a series of log messages more specifically. And you can see this is actually something that we were doing earlier with the etc password file that actually got logged. The kernel logged the fact that we were trying to do something with it. And there are a number of log messages that relate to different things that the kernel is doing. Up here, we're getting, actually this looks like boot messages to me. So we've got where the hard drives are actually being located. We've got ATA5, ATA6, ATA7, ATA8, and then here ext4fs, it's where the file system is being recognized and so forth. We've got a lot of different log files, and so let me take a look at the syslog file. This is kind of a default where things get dumped if they don't have another place to go, kind of a catch-all for a lot of different types of log messages. We've got the DHCP client up here at the top, DH client, where we've got a DHCP request and an acknowledgement of an offer, and a number of other applications are actually logging to this particular log file. You'll also notice here, for example, with syslog, I've got syslog, syslog.1, and then we go to syslog.2.gz. That's actually a particular program called log rotate that goes through and rotates the logs periodically so that we can keep multiple days or maybe multiple weeks worth of log files, so we can go back in case there was a problem. We can go and look at the older log files, but the older ones get zipped up and compressed so they don't take a lot of disk space. If you ever run into a situation where you're having problems with a particular application or with the operating system in general, you probably want to come to var log and start poking around in the log files and see if you can see the messages. They are in English, more or less. Once you've started looking around at them a little bit more, you'll actually start to make more sense of them. And they aren't really that hard to read once you get used to it. On the left-hand side, let's just take one of these, for example. I'll walk you through it quickly. So we've got the date and the time that the log message was created. Rosebud is actually the system name. Avahai Daemon is the name of the application. And then we've got the actual message, invalid response packet from host 10.211.55.1. And the others are pretty much the same. Sometimes they'll look a little confusing, but if you look at it long enough, you'll start to see that there are generally messages there that may provide you some insight into what's actually going on and hopefully point you in the right direction so you can start figuring out how to go fix the problem that you were looking in the log file to understand to begin with. In this lesson, we're going to be talking about service management. Services are the programs that actually run in the background. You'll see services on Windows systems, for example, and there's actually a services program that will give you the status of all of the different services that run. When you run a service on Windows, as I said, it runs in the background. It starts up probably at boot time, and it just runs without you having to worry about whether it's running or not. It's just there. When you need it, it's always around. So there's a number of programs that run as services under Windows. And under Linux, particularly with Ubuntu Linux here, which is what we're looking at, all of the services are just scripts that start up programs, and there are different components to the scripts, so you can stop, start, restart, check status, and maybe do a number of other things. We've got the scripts located in etc init.d, and actually, if I take a look here, we're going to see that etc init.d actually points in some cases to other locations, but in reality, what we've got primarily is etc init.d is the source for all of the scripts. If I were to go up and take a look at, let's say, etcrc3.d, which is a run level, and I take a look at what that actually looks like, all of these files in this particular directory are going to point to the script that is actually located in init.d. Again, we've got this list of scripts in etc init.d, and I could certainly do something like init.d/smbd and do status on that, for example, and I would get a status back. I can also use the service command, and with service I could do a status-all, and that's going to check all of the scripts in etc init.d and run a status on all of them. You'll see the minus is where we've got a service that's not running, the plus is where we've got a service that is running, and the question mark is where we've got a service where we actually got a response that didn't make much sense. So for example, we've got one for speech-dispatcher. So I could do init.d speech-dispatcher, and then I'm going to run a status on that. And actually what we got here is disabled. The status all is actually looking to see whether it started or whether it stopped. Disabled doesn't make any sense to status all, so we can just run an individual status. Now, the other thing I can do with the service script is I can say smbd stop, and now that's stopped, and I can now do a start, and it tells me that it has started. Now, of course, I can always check to make sure that it is running. We're going to grep for smbd. And sure enough, I've got smbd running, and there it is right there. I can use that service script to do this manipulation, and as you saw, we actually got some responses back, and again, I can run a status-all, see all of the different scripts that I've got. Again, I can see what the status is. If I've got one that's not running, I can start it up. So rsync, for example, is not running. And I could do service rsync and start and know whether that's configured to actually run or not. And in this case, we didn't actually get it to start up. But if I wanted to start a particular service, I would do service and then the service name and then start. So I can manipulate the services either directly from etc init.d, or I could use the service command to change the status of services, whether I'm starting them or stopping them, or simply just checking the status. In this lesson, we're going to be talking about managing processes. A process is a running instance of a program. So for example, if I were to start up Firefox here, I'm actually starting up a process, and Firefox is actually that process that I have just started up. Any program that is running is a process, and it has a process entry in the process table within the operating system. You may want to know how you would go about seeing all of the processes that are running. Well, I can run PS, which is my process statistics, and you can see I've got the process ID here, and then I've got the teletype terminal that we're running from, and I've got the time and then the command that's actually running. All that does is shows me all of the processes that are running within the context of this particular terminal window. So I could do, for example, a PSA, which is going to show me a larger list of all of the processes that are running. I could also do a PSEAF, which is going to show me basically the same list but with additional details. And so you could see I've got some environment variables listed there. I can also use PSAUX, and that's going to show me all of the processes running on the system regardless of what user I'm actually running as. So let me scroll up to the top here, and we're going to get to the column list. Here's what I just ran, PSAUX. You can see the first column is the user, and then I've got the process ID, the percentage of CPU, percentage of memory, and so forth. I've got a number of entries for the root user, and there's a lot of services that are running there. I've got nobody user, color D, RTKit, And then, of course, my user, you can see all of the different process entries, and these are all processes that are running right now. All I'm showing you, though, is the list of processes at that moment that I run that command. I may actually want to have a list that's constantly updating. Before I do that, let me show you how I would go about narrowing this down. So I can use grep, which we've looked at before, and I'm going to look for Firefox. I've got two entries here. The first one is actually the Firefox program that I've run, and you can see it's userlib Firefox. The next entry is actually the grep command looking for Firefox. So I'm going to see the Firefox entry as well as grep. Since I passed Firefox in to grep, it shows up in my process list because it's a command line argument. So let me go back to the list that's constantly updated. There's a program that I can run called top, which is going to show me the list of processes that are running right now, and it's going to update itself periodically. You can see that Firefox was actually there, and so I've got Firefox. Let me actually close Firefox here, and then Firefox disappears from the list. You see previously it was up towards the top. Now I've closed it, and it's going to disappear. Let me start it back up again and come back to this window here. Now you can see Firefox is right at the top, and it should drop down in a second or so as it kind of settles in and doesn't need as much processor utilization once it's started and actually just kind of sitting there not doing anything. And now you can see it's dropped down to number 4 right now. So again, we've got the process ID, we've got the user, those are the columns that we've got. We've got a prioritization value because the CPU needs to know how it's prioritized, whether it's more important than other processes or not. And then we've got some memory statistics and the percentage of CPU and memory that are being used. So lots of different information about the processes. Up top, we've got some more system-specific information. So we've got the percentage of total CPU in use, and then we've got the uptime. At this point, we've been up 11 minutes because I just installed some upgrades to the operating system and had to reboot for that. And I've got my load average, which is an average of the number of processes that are in the CPU queue at this particular moment. And there are 3 entries there for right now, and then there are 2 past entries for that. So you can see kind of a historical load average over a period of the last several minutes. So we've got PS, and then we've got top, and those are a couple of different ways you can look at the processes that are running on your system at any given time. In this lesson, I'm going to take another look at process management. Previously, we looked at PS and we looked at top, which were great ways of getting a list of all of the processes that are running on the system. And we may actually run into a situation where we want to kill a process. Now here I could just close the window. It would stop Firefox. If I had a case where it was a process that didn't have a window attached to it, or it was maybe a process that was stuck and wasn't responding, what I could do is I could actually kill it from the command line using a utility called kill. And as always, we can do man kill, which is going to show me the manual page for kill. You can see we're sending a signal to a process. A signal is actually a way that the operating system communicates with processes, and I can send signals from one process to another process. The default signal that gets sent is one that's going to terminate the program. And let's get the process ID here for Firefox, and I'm going to use grep to do that. So PSAUX, and then I'm going to pipe that into grep and look for Firefox. So now I've got my process ID, and my process ID right here is 3261. So if I right-click that, I can copy it. And of course, I could just type 3261. It's just 4 digits. But copying and pasting is just as easy. So now I can do kill and paste. So I'm killing a process ID. And as soon as I hit enter here, you should see this Firefox window that's right here just disappear. So kill 3261, I hit enter, and sure enough, the Firefox window disappears. Sometimes I don't want to go to the effort, though, of looking up the process ID. It's actually a lot easier to just use kill all. And let's do man kill all. You can see I can kill processes by name. It's effectively the same thing as kill, except I can do Firefox here for the parameter that I'm passing, or the argument. So I can say kill all Firefox. And sure enough, Firefox goes away. Now, I mentioned the case where you could send signals, and the default signal is going to send a termination signal to the process. Sometimes, though, that's not actually enough. And I can send a specific signal. In this case, I'm sending signal 9, which is a step above that and just says, flat out kill this. Forget what's going on. Forget if the process isn't actually responding or not. I can just do kill all -9, Firefox, and it kills the process regardless of what state the process is in. It's going to kill that process. So we've got a couple of ways of killing processes. We can kill that by the process ID, as we did here, where I did kill 3261, or I could kill by the process name, which would be using kill all, and then I specify the process name. The nice thing about kill all is if I've actually got a number of processes that I want to kill, they're all from the same program, it's going to find all of them and kill all of them, regardless of how many there are. So it saves me the effort of looking up individual process IDs for all of them and then typing all of those in, or even copying and pasting. If I do kill all process name, it's going to kill all of them that it finds. So that's managing processes through killing them, which you may have to do from time to time. In this lesson, we're going to be talking about building software. In most cases, you're going to have everything that you need either already installed in Linux or something you can get from an Ubuntu repository by using apt-get. Some cases, though, you'll find that there is software that you can't actually install in that fashion, and you may have to build it from source or build it by hand. Now, I've got a package here that I've just downloaded the source code for, and this is Nmap. And in this case, it's not actually a package, it's just a bundle of source code, and we're going to go build the software by hand or build it from scratch. So the first thing I need to do is I need to extract that tar file, and I'm going to say nmap. Now you can see I've done something a little bit different there. I've done tar xjpf, and that's because what I've got here is a bzip file. And tar can handle that, but it's different from the tar xfz, which would be for zip files or GNU zip files. I would add a jp instead of the z in order to do the bzip file. So now if I do an ls, I've got my nmap directory and I'm going to cd into it. Now the very first thing I'm going to do is a configure. And a configure is actually a script that is written and it's provided in the package, or in the bundle rather, and it allows me to just run this script and it automatically goes out and checks to make sure that I've got everything in place that I need in order to go build this software. So it goes and checks for libraries, it checks for headers, it makes sure that my environment here is sane from the perspective of what I need in order to build this software. When this is all done, what I'm going to have in place is I'm actually going to have what we call a makefile. And I say what we call a makefile. It's actually named makefile, and we can take a look at it here. And it may look a little confusing. What we're actually doing here is we're setting a number of variables, and we've got nmap version, nmap update channel, name, URL. You can also see down here we've got a prefix, and what that says is I'm going to set a variable called prefix and make it user local. Underneath that, exec prefix is the same as prefix in this case. I could set the binary directory or bindir, so all executables or binaries are actually going to go into that directory. And in this case, it's user local bin. So we set a number of other variables like that, and I can keep scrolling down, and you can see we set some flags for building. But in reality, you don't have to worry about any of that, because what I'm going to do here is I'm going to type make, and make is going to go read the make files, and it's going to go do everything that those make files say to do. It's going to go compile all of the source files that it has, and it's going to go build all of the software. When it's all done, we're going to have software that's ready to be installed. So you can see it's just zipping through, it's compiling. In some cases, it's doing some pre-processing by changing some things around if it needs to do that. In this particular case, we've actually got a library that it wasn't able to find. Let's say, though, that it actually completed successfully. What I would do would be to just make install. And most of the time, these packages will just compile, they'll install cleanly. Every once in a while, as in this case, you have to go do a little bit of digging. Even though the configure script is going to go and find a lot of things for you, and they do a really good job with those, every once in a while, you'll run into a case where we don't have the right thing installed. So in this case, I would actually have to go and install the right packages that I need, the right libraries that I need in order to finish this particular process. Right now, though, since this isn't going to be something that you need to do on a regular basis, all you need to know generally is you're going to run the configure script, and then you're going to run make, and then you're going to run make install, and you're going to use either the root user to do that, so if you log in as the root user, or in this case, I'm using a utility that gives me root permissions called sudo. And if I want to install into one of the system directories like user, user local, user bin, and so forth, I need root permissions to do that. So I need to either change my user over to root, or I can use sudo, and it will give me temporary root permissions in order to do that. So that's building software. It can be a little complicated. Sometimes you have to do a little bit of troubleshooting. Most of the time, though, it's going to work right out of the gate, and it's going to work pretty well. You'll be able to get a piece of software that isn't normally in the Ubuntu repository. In this lesson, I want to talk about a couple of useful utilities. Now, one of these utilities we've been using a little bit so far, and it's grep. And grep actually stands for global replace. And I can use grep to search for string patterns in files, or in basically anything I feed to grep. So let's just grep for the word file in everything in my current directory. That's what the asterisk here means. It's a wildcard that says use everything that you can find. I've got a file here called errors.txt, which apparently has a number of matches for that word file. You can see all of those there. And if I scroll down, I've got examples.desktop here. We've got URL equals file. And then I've got, looks like 3 files here that match the word file. Now, you'll also see that I've got some listings here that say is a directory. When I just search for asterisk, it's looking for files. It's not actually looking for anything in a directory. For that, I would need a recursive search, and I could do grep -r, and again, I could do file and then asterisk. And in this case, I've got a directory underneath that apparently has a lot of matches for the word file. And so we've got a lot of different things. Now I don't have the error indicating that it was a directory. So I can use grep for a lot of different stuff. I can do, for example, we looked at this earlier. If I did AUX and then I could grep for bash. So I'm getting a process list and I'm just looking for different things based on the string that I have provided. And I'm using the pipe, and the pipe, as I've mentioned previously, says take the output of the first command and send it to the input of the second one. So this is really helpful, and it's one place that you can use grep an awful lot, is this piping the output of one command into grep to look for specific things. So for example, earlier we were talking about, let's say we were talking about looking for packages, and I wanted to do something like look for Apache, which is the web server. Well, if I do that, I'm going to get a lot of listings here. Well, I want to narrow that down, so I'm going to grep for, let's say, PHP, which is a programming language. Well, now I've got a much more manageable list. So grep extracted only the entries from apt-cache search and showed me something more specific. So that's what I can use grep for. Now, another useful utility, let me just clear the screen here. Another useful utility is sed. And sed is stream editor, well, that's what it stands for. That's actually what it does. So if I were to do, this is true, for example, I'm just using echo and it says this is true. Now, if I were to use sed on that, and again, I'm going to use the pipe because I'm going to send the output of echo into the input of sed. Now I'm going to say sed, and I'm going to search for, and this / here is actually my indicator that I'm starting a string. So I want to say true here. And now I do another / and I want to replace true with false. So I'm doing a stream edit and I'm searching for true and I'm replacing it with false. You can see that even though I said echo this is true, I used sed for this is false. Now what I can also do here is let's do a grep on file in my current directory. And then I'm going to send that into sed, and I'm going to replace file with non-file, for example, just to have something to replace it with. Now you can see everywhere that previously I had file, I replaced it with non-file, except here you can see I replaced the first file with non-file. In order to replace all of the instances across a line, I would have to do G at the end that just says globally. Now you can see I've replaced here my file with my non-file, and at the end of the line here where it previously said file, it says non-file. Now I could certainly take the output of one file, so let's say cat my file, and I'm going to send that into sed, where I'm going to change file to, let's say foo. And now I'm going to redirect the output, which would normally just come back to the screen. I'm going to redirect the output into my foo. Now, if I cat my foo, I have changed the file into foo here, which you can see. So you can see a stream editor is pretty handy for making a lot of changes to various output, including a lot of quick and easy changes to files where otherwise you'd be going into an editor and trying to use the editor to make a lot of those changes. You could just use the stream editor, do it right here on the command line, and have it all be done for you. I've mentioned before that Linux is actually the operating system or the core of the whole suite that is Ubuntu. Linux is the kernel. It provides the software that interfaces between what you see and the hardware underneath, whether it's memory, whether it's disk, whether it's the processor itself. Linux is the kernel that provides that interface. And one of the nice things about Linux is it gives us the ability to actually install additional functionality into the operating system. And so what I'm going to show you here is actually installing additional functionality into the operating system. We've got modules. These are kernel modules that I can install into the operating system, meaning that they run at the very highest level of privilege and they can interact directly with the hardware. In this case, I'm going to cd into kernel. You can see I'm in /lib/modules, and then the next bit there is actually the version number of the operating system that I'm running. So that's the version right here. So I'm running Linux 3.11.0. That's the kernel version number. And I'm going to drop into kernel. And you can see here I've got a number of directories. I'm just going to dump into drivers, and then I know powers underneath that. Now, in order to see the modules that are already loaded, I can use a utility called lsmod, and that's going to list the modules that are already in place. So these are all of the modules that I've got here. And you can see the first module there is Visa FB, which is the Visa frame buffer for the actual display driver. And there are a number of other ones. If I scroll down a little bit, you can see the Bluetooth driver down here. and the parallel port. And you can see E1000, which I happen to know is the network driver. And we've got PS Mouse and Sound Core. So a number of things that may look familiar to you. And what I can do is actually install a module. And I'm going to do that here. So I'm going to say, first of all, I need to be root. So I'm going to use sudo that I've mentioned before. And I'm going to say insmod for insert module. And then I'm just going to give it the module name here. So I've got 88pm860x_battery.kernel object or KO. And I'm going to insert that module. In this case, it's not going to find the hardware. And so it doesn't really do me any harm to insert this particular module. So we're just going to do that. And now if I do lsmod, now if I scroll to the top, because that's where I'm going to find it, you can see up here, it's actually there. So I inserted the module. Let me scroll up a little bit more. I inserted the module here, and then I did an lsmod, and you can see that the module is actually installed, and it's running right now. Well, let's say I don't actually want that there. So I can do an rm mod, and I can say 88pm860x_battery, take that module out. So I'm going to effectively unload that module and remove it from the kernel memory space. Now if I do an lsmod, again, I'm going to scroll back up, and you can see that that battery module is no longer loaded. I have unloaded the module. This, again, is one of those things you're not going to do on a regular basis. Sometimes, though, you may need to load up a driver that the operating system isn't finding itself. You may have an extra module that you need installed for whatever reason, and you can certainly get that module. And again, this is how you would look at the different kernel modules that were in place and also insert them into the running kernel and also remove them. If I used rmmod, I could remove it, insmod, and I can insert it. And then lsmod is going to show me all of the running kernel modules at this given time. In this lesson, we're going to be talking about doing some changing of the way the kernel operates. Now, we've talked about the kernel previously, and the kernel really is the operating system. The kernel is the piece of software that actually sits between all of the pieces that you are interacting with. So this desktop environment here and this terminal window, for example. And it interfaces between all of those components and the hardware underneath. So it makes sure that all of these processes get into and out of the processor so that they get run. It manages memory, it manages hard disk. It does all of the interaction with the hardware. So that's what the operating system does. That's what the kernel does. And there are a number of parameters within the kernel that I can actually change. So I can change some parameters using a utility called sysctl. And there's actually a file called sysctl.conf that lives in Etsy. We can take a look at all of the different parameters that I can change. And we'll just take a look at a couple here. So I've got the ability to forward packets using IPv4, and there are a number of network settings here. If I scroll up, I can take a look at some of the other ones that are there. Most of these here have to do with network. And we've actually looked at some of these before when we were looking at the sys pseudo file system. That's where all of these parameters actually live, quote unquote, on disk. In actuality, they don't live on the physical hard drive. They're just presented in the file system, as I had mentioned previously when we were talking about pseudo file systems. But sysctl I can actually use to make changes to these things. So let's take a look at net.ipv4.ip_forward. And I can use sysctl to check the status of any of these individually. Sysctl net.ipv4.ip_forward is going to give me the setting of the IP forward parameter. Well, I can also use that to change the parameter in real time. And as soon as I change it, the kernel gets it, and now the behavior of the operating system has changed. You can see that I've actually changed that there. If I were to reboot at this point, though, that change would actually not persist across the reboot. In order to actually fix that, I would have to edit sysctl.conf. I would have to go down to the line that says IP forward. I could comment that out. Now I'm going to write it out. Now what I can do is sysctl -p, and that's actually going to make that persistent now. So I've made that change. Now when I reboot it, I'm actually going to get that behavior permanently, no matter how many times I reboot it, because I've put it into the file and I've told sysctl that this is the behavior I want permanently. So -p means make persistent or make permanent. To undo that, of course, all I have to do is go back in, change that line again. I could actually comment this out. And now I'm going to do -p again. And now we've got a change that I've actually undone. So all I have to do is use sysctl. I can make things persistent. I can use sysctl to actually make these changes, or I could use the sysctl -p to permanently make a change that I had made on the command line. So I can use sysctl to make changes to the behavior of the operating system, and I can do that in real time. That's what the sysctl utility is actually for. In this lesson, we're going to start taking a look at user management. And the first thing I want to show you is really an under-the-hood thing. It's where the user database actually is on a Linux system. This may surprise you a little bit. I'm going to take a look at etc password. And you'll notice password is spelled without the OR. Again, Unix goes back about 40 years, give or take, actually a little more than 40 at this point. And they were really interested in conserving not only keystrokes, but also the memory it took to actually store information. And if you could save a few bytes by cutting the name of your program down, even better. So in this case, it's just a file name, but it works pretty well. So passwd, and I can take a look at that here. And here's a list of all of the users that are on my system. And you can see we've got, for example, the bin user. The X is where the password actually used to be. And in this case, it says X because it says the password is stored somewhere else. After that, you can see all of the fields here are delimited by colons. So after my password field, I've got my primary user ID, which is a number or a numeric value. And then I've got my group ID. And then after that, I've actually got the name of the user, so the visual name or the name that you want to show. In this case, it's the same in both instances. After that, I've got the home directory for the user, and then finally the default shell that that user would use. So that's what the password file would look like. And actually, if we scroll all the way down, it may make a little bit more sense here. I've actually got my username. Again, my password is stored somewhere else. I've got my primary user ID and my group ID. And then I've got my real name or the display name. After that, I've got the home directory. And finally, /bin/bash, which is the default shell that I would use when I logged in. So anytime I log in, that default shell is actually what's going to execute for me. Now, let me take a look here at the password file. And again, that's just a plain text file, and it's called shadow. Now, it's called shadow because it's sort of a shadow of the password file, except in this case, we actually get passwords where there are passwords to see. Now, most of these, there aren't passwords set because we don't really want these users logging in. So there's no password there. It's only when you get down to mine that you can actually see what the password is. And this password, of course, is hashed. And so you wouldn't be able to just see my plain text password. It's stored with a cryptographic hash. So you can't just read it in plain text. You'd have to actually do a brute force attack against it because a cryptographic hash can't even be undone to create the plain text password back, you'd have to hash a bunch of plain text passwords and then compare them against the hash that we've got in order to see whether you've got the password or not. So it's really kind of a brute force process in order to crack that sort of password. Doesn't mean that it can't be done, just a lot more difficult, certainly, than seeing a plain text password. So the two files, anytime that we're working with users that we're going to be dealing with, are Etsy password and Etsy shadow. The other one to look at is Etsy group, which is a list of all of the groups on the system and then the users that belong to those groups. So you have your primary group ID, which is the one that your user is just a part of, but I can also add myself to a number of other groups, and you can see here in the groups file that my user has been added to a number of groups, and those additional groups may give me additional permissions to files and other resources on the system if I belong to those groups. So those are the files that we would be manipulating anytime we made changes to users and groups on a Linux system. In this lesson, we're going to talk about adding users. Before I add a user, there's a couple of things I need to know. The first thing I actually need to know is what group I'm going to put that user in. So I'm going to take a look at the groups that we've got on the system, and I can make a determination at that point which group that I actually want this user to be a part of by default. Of course, I can also add users, but in this case, I don't want to add a user. I just want to add the user that I've got to an existing group. And I saw staff here a second ago. That's a pretty good one. Right there is staff. So let's add the user to the staff group. Again, I'm going to use sudo because I need to have administrative privileges or root level privileges. So I'm going to use sudo. Then I'm going to do user add. And I'm going to say the directory that I want to use is home. So this is my home directory. And the directory I'm going to use is /home/rick. And then my shell. So we talked previously about bash being the shell that I use. Anytime I log in, it's going to execute this program. So I'm going to say in this case, my user is going to use /bin/bash. My group is going to be staff. And then I actually want user add to make the home directory for me. And so I'm going to add the user Rick with these parameters. Now, there are other parameters that I could set, including my real name, and that would get added to the password file as well. But in this case, I'm just going to set the basic parameters here that I need. So I need a home directory, I need a shell, and then I need a group. Now, if I take a look at password file, you can see that it actually added it. And this is my user ID here, this 1001. And then the group that I added this user to is 50. But what that says is that user belongs to that group. So let's say I want to make a change to a user. I could do user mod, and now let's say I want to put the user in, let's say, the ADM group, and I want to do that change to user Rick. Now, if we look at the password file, you'll see that the group ID here has actually changed. It's now 4 rather than 50. So I get all done with that. I actually want to delete the user. I can do that by doing user del. So now I just take a look at the password file, make sure that the user is gone. And sure enough, at the end, the user is actually not there anymore. So in order to add users, you would use user add, and we can take a look at the man for that. We're going to create a new user, and we've got a number of parameters we can use, like comment, for example, in home directory, expire date, inactive, the group ID, so on and so forth. So I can add a lot of parameters to user add, but there's really a couple of things that you have to have. And of course, I have to use the user ID. If you want this to be interactive at all, it's got to have a home directory, and it's also got to have a shell. Now, the one thing that we didn't talk about was password. In order to set the password for that user, I would have to do this. So I'd say sudo password Rick, If I wanted to change my own password, I can just run password here, and it's going to prompt me for my current password. And then if I type my current password in, it's going to prompt me for the new password. That's how that actually would work if I wanted to change the password. So again, I could do password for my own user, or I could do password for another user. If I were an administrator, I can always change passwords for another user. Once we've added the user, we've created a password, I can modify it using user mod, and then if I've got a user I don't need anymore, I can just use userdel and delete that user. In this lesson, we're going to talk about groups. Groups are really fundamental to user management because the user has to belong to a group, and that group has a set of permissions that are associated with it that then cascade down to the user. So I add my users to groups, and I do that using this group file. So let me just edit this group file here. Now you can see my user has been added to a number of groups here. That means all of these groups, the rights and permissions that these groups have, my user also has. Now I could add myself to another group here, and that's all I need to do to give myself permissions to that group. I can also add groups. I can add this group here, and if I were to take a look at the group file, you would notice that the group that I just added gets added to the bottom here. I can also change groups, much like I could with a user. I could do group mod, and you could see I change the group ID to a group ID that I wanted to. So let's do this, for example. So group mod, and I want to say G of, let's say 5,000. And then I'm going to say the group is that one. So now if I take a look at Etsy group, I've actually got the group ID of 5,000. Doesn't really mean much other than that's a numeric identifier that the system actually knows the group as, and we use the name so that we can make it easier to understand. But the system really uses the group ID, so it uses the numeric value, and it sets permissions with that numeric value. When it comes time to doing things like displaying permissions in a directory, it's going to go look up the numeric value that corresponds to this right here and give the name when it does these printouts. What's actually stored in the file system is the group ID and the user ID. The system does a reverse lookup of those IDs and gives the printable name that's going to make more sense to us. For our convenience, it's not actually stored that way. So groups have some power in terms of granting users additional rights beyond those that are granted specifically to the user. You add the user to a number of groups, and then all of the rights and permissions that that group has, the user gets along with the group. Another useful utility for system management is Cron. Cron is actually used to automate tasks, and it's probably not something that you're going to use a lot, so I'm going to give you a quick overview of the capabilities of Cron. With Cron, let me actually change into the Cron directory, and I've actually got a file here called Anacron, and there's what we call a Cron tab here. So the cron tab is a set of parameters around how a cron job is actually going to work. So you don't need to worry too much about that. You're going to use the default settings in order to actually add jobs yourself, more than likely. So let's take a look at one of the existing directories where you would put cron jobs. I'm in cron.daily, and cron.daily is where you would put jobs you wanted to run once a day. I can take a look, for example, at log rotate. So I had mentioned previously with log files, they get rotated on a regular basis. So let's take a look at log rotate. You can see this is just a set of commands that are going to be run, and cron is the task that actually runs this set of commands. So this actually does the log rotation. This is a set of commands that's going to go in and rotate all of the logs on a daily basis. Cron is actually the program that runs all of these individual scripts once a day. Now, there's also cron.weekly, for example, so there are some scripts that are going to run weekly, and then cron.daily we've looked at, and I can also take a look at cron.hourly. And in this case, there's not actually anything in cron.hourly, but if you had a job you wanted to run once an hour, it's going to run out of cron.hourly. So I could actually add a file here. I could, for example, my cron job, and I could create a cron job here that would run once an hour. And once I saved it, I could actually just have cron execute that automatically. I don't have to do anything beyond that because cron is going to go through every file in that directory once an hour and execute them no matter what's there. Same thing on the daily and weekly. All you have to do is put a little script into those directories and it's going to execute them automatically. And it's going to execute them in basically alphabetical order or in ASCII order, really. So what we've got here is 0 anacron, and it's named that to make sure that it is the very first job that runs. Everything is going to get executed in ASCII order, so 0 is going to be the lowest value that we could actually use here, so that's going to be the first job that gets run. If I were to name something, for example, my cron job, and let's say I put it into cron.daily, it would actually execute after mlocate, but before password, because that's just the order that it is. So ml comes before my, and of course my comes before pa. So it's going to execute in those orders. Now again, you may never have to deal with cron jobs, but it's helpful to know that they're there and they're doing system maintenance activities, and if there does happen to be something that you want to script up and run on a regular basis, doing whatever it is, downloading a file, for example, from some website, or checking to see whether a particular internet host is alive, you can actually do that with cron. Just drop it into the right directory based on the schedule that you want to use, and cron will take care of running that automatically for you. In this lesson, we're going to be talking about sudo. Now, I've used sudo before, and sudo is really just super user do. So I want to execute something with administrative privileges, I'm going to use sudo to do that. So if I were to try to cat etc shadow, because that's where the passwords are stored, I don't have permission to do that. So all I have to do is sudo cat etc shadow, suddenly I have administrative privileges. Now, there's a file that is used to manage these privileges. So let me show you that file here. I'm going to have to use sudo because it's a protected file. And in order to look at that file, I'm going to use the command vi sudo. And that's going to bring up the sudoers file in an editor for me. The sudoers file is protected. This is the easiest way to actually edit that file. And of course, I've got to be root in order to do that. Now, I've got some parameters here in order to determine who I'm going to give sudo permissions to. You can see the file is actually commented pretty nicely. So members of the admin group may gain root privileges. You can see I've got a %sign admin that says the group admin gets all permissions, and if I wanted to say all permissions without specifying a password, which is what I've got for my user, you'll notice every time I run sudo it doesn't prompt me for a password. I can specify no password for all of the commands. Now I do this just because this is a virtual machine, sits on my local network. Nobody other than me is ever going to get to this just because of what I've got it set up to do. Normally, and by default, sudo would actually prompt you for your password, not the root password. It's going to prompt you for your password. That just makes sure that you are really the correct user trying to gain a privilege escalation and execute something as root. This is the default file, other than I made the sudoers change here, and again, I added the no password in. I can also specify very specific commands for specific users to be able to execute as root. So I can really lock down the things that I can allow users to gain privileged access to. Commonly, though, you're going to give a user or maybe a couple of users the ability to gain access to the administrative account, and that's just going to be what you do. So you give yourself sudo privilege, and you can sudo to do anything that you want. Now, when I do things like, let's say we go to taking a look at the users, and let me scroll down here so we can see the users. When I do this, bring up users accounts, and I do the unlock, it's actually asking for my password, and it's checking against the sudoers file. So even if you're using the GUI things, you're still getting sudoer privileges or sudo privileges in order to do administrative functions, which of course is what users are. Adding users and managing users, that's an administrative function. You're going to use this sudoers file. By default, when you create a user under Ubuntu, it gives you the permissions to escalate to this super user status to do certain things. And again, I just added the no password in for myself because I'm a little lazy and I don't want to type my password for all of the administrative things that I do, especially when I have protected my system in other ways. The reason that we do that is if you're in an office setting and you leave your system unlocked for whatever reason, somebody can come by, type sudo, and let's say we do sudo rm -rf asterisk. That's going to erase every file on the system. It's kind of a classic blunder, but it's something that you don't want to do. Somebody could actually do that if you gave yourself sudo permissions and didn't have a password associated with it. Anybody could wander by and do that. So in order to protect against mischief and mayhem and all of those sorts of things, we password protect access to the administrative account, but we don't have you log in directly as root. We have you log in as your own user and then just escalate as you need to. Once you've typed your password in, that will stay cached for some period of time of a couple of minutes or so, and you don't have to type your password again during that period. Once that timeout period expires, then you'll have to type your password to re-authenticate. That's how sudoers works, and that's how you would actually make changes to the sudoers file in order to give permissions or alter the permissions that you've got to gain super user access. In this lesson, we're going to start talking about networking. The first thing we need to talk about when we talk about networking is network interfaces. On Linux, there's actually a utility that will show you all of the interfaces on the system. Under Windows, if you've ever run across this, there's a utility called ipconfig. Now, under Linux and under Unix, it's always been interface config or ifconfig. So I do ifconfig and I see the different interfaces that are on my system. In this case, I've got one Ethernet interface, which is ETH0. That's actually the name that's used for the interface. It's how I would refer to it if I ever need to make changes to it. On top of that, I've got a loopback interface, or LO. Loopback, it's really a testing term, and it's used if you want to communicate with only the local machine. It loops back to itself, never leaves the system, and it's always a local loopback. You can actually see it says right here, local loopback. It just loops back to itself. I've got two interfaces, so I've got ETH0 and I've got LO. I could have multiple interfaces, of course. If I had more interfaces in my system, they would all show up here. And just to make sure that that's not true, I could do -A, which is going to show me all of the interfaces. I could actually just look at the interface configuration for one interface. If I did ifconfig ETH0, it's going to show me the ETH0 configuration. We've got IP address. We've got all of the other information, so the broadcast address here, for example, and we've got the network mask. Everything you need to know about your interface shows up under ifconfig. You can also see I've got an internet v6 address or IPv6 address, and that shows up right down here. Those are my interface configuration details. If you ever want to know anything more about your network interface, you would go there. I could also go up here and I can show the interfaces that I've got. You can see I've got a wired connection 1. If I wanted to actually make changes to it, I could go here and I could edit it. In this case, I've got my MAC address, which is the media access control address. And if I go over here, it says automatically connect, IPv4, I've got DHCP. So you can certainly make changes using the graphical interface and see some details there using the GUI, or you can be in the console and just use the standard command line utilities like ifconfig here. Now we're going to look at some more network utilities coming up in the next several lessons. One thing I may want to do at one point is actually look up information about IP addresses and host names. So in this lesson, we're going to be talking about actually looking up DNS information. DNS is the domain name system, and you may be familiar with it when you go to a website. You're going to go to www.infiniteskills.com, for example. Now, that is a host name. Actually, let me bring it up in a web browser. If I go to the host name, www.infiniteskills.com, that's actually the host name, and it refers to a specific system or the IP address of a system that actually is the web server for the domain infiniteskills.com. Without getting into all of the details about how DNS works, which would be a whole different thing, we can talk about how you can actually look up information from the domain name system. If I wanted to know, for example, what the IP address was for www.infiniteskills.com, I could do something like this. I could use the host command. Host is going to do a DNS query, and it's going to tell me that the website, www.infiniteskills.com, or that host name, is an alias for infiniteskills.com. And furthermore, that host name, so even though it's a domain, it's also a host name as well. That particular host name has an IP address of 204.12.117.93. That's one way of looking up an IP address. I can also do an NS lookup, and I can do the same thing here, and I should get roughly the same responses. Sure enough, I get 204.12.117.93. In this case, it's telling me what the DNS server it used to look up that information was. And all I really get back here is I've got www.infiniteskills.com. It says the canonical name, which is really the alias. Canonical name is a DNS term, and it's sometimes called CNAME, which is short for canonical name. The name of the host that actually owns the IP address is infiniteskills.com. And once again, we get the IP address down here. Now, that's another way of looking it up. I can also use the utility dig. And dig is going to show me all of the root servers in that case, but if I want to do dig infinite skills, it's going to give me a lot of details about the query. So it's telling me the query that it actually used. You can see the question here is infiniteskills.com, because that's actually what I looked up. So let me change that here. Now it should give me the question section is www.infiniteskills.com. We are looking for an address record or an A record. And the answer that got back is that www.infiniteskills.com is a canonical name for infiniteskills.com. And then it further looked up infiniteskills.com for us, and it found it has the IP address of 204.12.117.93. I've got 3 different ways of looking up IP addresses. Of course, I can also do the reverse way. If I look up, I'm just going to copy that. So let me dig that. And I get back that it actually doesn't have a reverse address. In some cases, I'll get a reverse address, meaning the IP address will actually resolve to a particular host name, and they don't always match. And certainly in this case, they don't match. There's not actually a reverse address. I could try it again just to see if that was a bit of an anomaly, and sure enough, I get not found from host. So that IP address doesn't actually have a reverse entry. That's perfectly okay. It's preferred that there's a reverse entry, but it's not required. Nothing's going to break if that's the case. But we've got 3 different utilities to do DNS lookups. I've got dig, I've got host, and I've got NS lookup. All three of those great little utilities. Depending on what it is you're looking for, you may choose one over the other, but all great utilities for grubbing around in DNS and learning a little bit more about IP addresses and host names and the different types of DNS records that are available. In this lesson, we're going to take a little bit more of a look at DNS, and specifically, I'm going to take a look at how you would change the DNS servers that you're pointing to. Typically, you would have a local DNS server that you would refer to, and that's where your system would send its DNS queries to get those resolved into IP addresses, or if you're doing a reverse lookup, looking up a host name from an IP address. Now, you would normally do a local lookup, and that's really to keep the traffic local so you're not sending a lot of queries over wide area links and using up bandwidth and so on and so forth. However, there are a number of places where you can actually use what are called public resolvers. And let's take a look here, before I get into that too much, at the file where the name servers are actually stored. And you can see at the very top here, it says, "Do not edit this file by hand, your changes will be overwritten." It's really managed by another process that loads this up once it has the information. And I'll show you where that comes from in just a second. I've got name server here, and the name server is 127.0.1.1. In this case, that's referring to the host operating system, so all of my DNS queries get dropped up to the virtual machine, and the virtual machine does the lookup for it, and that actually acts as the name server. I could change that, as this says if I change this file and change the name server, it's not really going to do much because it's going to be very quickly overwritten. And how I would do that here, the easiest way is to just go up to this up arrow, down arrow button at the top, and I can go to edit connections just like we've done previously, and I can edit this. Now we're going to go over to IPv4 settings, and you'll see this is set to automatic, which means all of the IP configuration information is going to be configured for me. I could do addresses only, which is going to open this up, and I could do like 4.2.2.1, and I could also add in 8.8.8.8. So I could add my own DNS servers if that's actually what I wanted to do, and that would get populated into the resolve.conf file for me, and I would use those DNS servers. Sometimes it's helpful to use public DNS servers if you've got a flaky DHCP server locally, or maybe you're in a situation where you don't actually have a DHCP server. You can go configure the DNS servers in this way so that it's actually using the DNS server that you want. In that case, the first one is I was adding in IP addresses that belong to level 3 that used to be GTE Internetworking and Ingenuity. And the second one is Google. And they both operate public resolvers. You can just add those IP addresses in and use those public resolvers rather than your local ones. You may also have an instance where you want to use maybe your own DNS server rather than the one that's handed to you. So you could go change your DNS servers if that's what you wanted to do. In this lesson, we're going to talk about some networking utilities that are really helpful for diagnostics and troubleshooting. The first one I want to talk about is ping. Now, when you think ping, you probably think sonar and the sound that's made when sonar is used. And it's just a ping, and you would get an echo back. Now, ping works the same way. What I'm doing here is I'm just going to ping an IP address. And this is an IP address that I use a lot because it's easy to remember. I know that it's everywhere. The reason I know that is that this actually belongs to a company called Level 3. And before that, it was GTE Internetworking and Ingenuity. And I used to work for those companies, and I know what this IP address actually goes to. And this IP address I should be able to get to from anywhere in the world just because of what it actually is. So I should be able to ping 4.2.2.1 from anywhere. And it's a pretty easy number to remember. I don't have to worry about doing a DNS lookup, so I'm just pinging an IP address, which in my mind makes it great for doing troubleshooting. I am avoiding everything other than the network issues. If I can't ping 4.2.2.1, there's something wrong with my internet connection, meaning I'm not getting off my local network. I'm pinging 4.2.2.1. You can see I've got my round trip time here. I've got 32 milliseconds is how long it took the echo request to get out and then the echo reply to get back. I can also ping, let's ping infiniteskills.com. And the first thing it does, of course, is a DNS lookup because we have to use the IP address. The network doesn't really know anything about host names, so it's got to be converted to an IP address. And then it's going to go ping that IP address. And again, we're getting our round trip times, and it's sending the echo request out and getting an echo response back. I've pinged an IP address. I've pinged a host name. That's all great. I know those systems are up and functional because I got responses back from them. Something else I may want to do is run a trace route. And a trace route is where I trace the path of packets through the network. Now, because we're using packets rather than just a circuit of data, and that gets into networking, which is way beyond the scope of this, but because we're breaking things up into packets, they can take different paths through the network. It's not necessarily common that that would happen, but it's certainly possible. And if I were to run a trace route multiple times over, let's say, a period of days, there's certainly every possibility I could run into multiple paths through the network to get to a particular location. So what you can see here is it took me 10 hops, which is 10 steps along the way to get to the location that I was actually pinging. And if you look here, you can actually see some location information. We've got, for example, Boston and New York, and we can see this is on level 3's network. Once we're in New York, we hop around a couple of times. We go through a core switch, and then we go to an edge router, and we end up at a.resolvers.level3.net, which is what 4.2.2.1 resolves to. I can trace route to an IP address. It gives me a sense of where the packet's going, and if I can get off my local network so I can ping, but I can't ping to a particular location, say I'm having problems getting to a website, I could trace route to that, and I'm going to get to a point where, and I'll show you that in just a second, I'll show you a good working trace route to a web address or a host name that happens to be a web server. So I'm going to www.infiniteskills.com, and we're running a trace route. We'll get the path to that particular IP address or that particular host, and then I'll show you one that's actually going to fail. And the reason why it's helpful to see a failure is because if you know where it fails, you'll know where the trouble in the network actually is. So now I've got my completed trace route. Now let me show you a trace route to one that actually shouldn't work, and I'll explain the reason why it doesn't work in a second. I'm trace routing to Microsoft's website, and this is going to take me most of the way there, and eventually we're going to hit a firewall that's actually going to block the messages that I'm trying to send, and eventually I should get to a point where I just have these stars, and that indicates I'm not actually getting responses. This is just going to basically black hole here. I'm going to keep getting these responses until I get to maximum number of hops, which in this case is 30 hops. So this will keep doing this up to 30 hops. Now that's what a failed trace route would look like, and I can see here MSN.net is the last network that I actually passed through that had some identifiable information to it. Then I got into a 10.22.40 network, which would be inside Microsoft's network. That's a private IP address. So I can certainly use traceroute to figure out where I'm running into problems. Ping and traceroute, excellent network diagnostic utilities. You may find once you get comfortable with command line and doing networking stuff that you'll use these a fair amount. They're just very basic, very easy to use, very, very helpful utilities. We've looked at diagnostic utilities with ping and traceroute. Let's actually look at some other utilities that could provide you information about your networking subsystem or all of the network aspects of your system. The first I want to show you is something called ARP. Now, ARP is the Address Resolution Protocol. We've talked about host names, we've talked about IP addresses. Underneath all of that is something called a MAC address, and it's an address that's attached to your network interface. Address Resolution Protocol is the protocol that actually matches an IP address to a MAC address. And if I do ARP-A, it's going to show me the ARP table, which means the cached list of entries for those resolutions and those mappings between IP address and MAC address. Anytime I'm talking to a system on my local network, so say between this system and my router, it's all done at the MAC address rather than the IP address. So I need the MAC address in order to communicate with devices on my local network. I can also do route, and I can show the route entries that I've got. And this is really showing me the routing table on my system. In this case, I've actually got two route entries. I've got my default route, which is where I send everything that's not a specific route. And my gateway here is 10.0.0.1. So that's where everything goes that is not destined for this network, which is my local network. My local network, I'm just going to send locally, and I'm going to send it out my local interface ETH0. Anything that's local goes to this route. Anything else goes to this gateway, and that gateway or my router is going to handle that. So I can look at my routing table on my system using route. I can also use netstat, and that's going to show me the same sort of thing. If I do netstat -rn, it's going to show me my routing table. I can also look at things like all of the systems that my system is talking to. And you can see there's a lot of streams here that are connected. This is actually communication that's happening locally on my system. And I've scrolled off the end here, so let me actually pipe this to less so we can see something a little bit more specific. You can see that I've got a number of systems that are listening, and these are services. So I've got actually 445 and 139 are going to be Windows file shares. And then I've got a couple of other ports that are listening. Looks like there was some web traffic that was happening at one point, and I've tried to close that. I can see the communication stream. Actually, let me pop this up and then run it again. So I'm going to go to, now let me run my netstat again. And you'll see I've got a lot of web traffic here that I've actually initiated, and so you can see the connection. Netstat is going to show you all of those network connections and the state that they're actually in, and those network connections can tell you what your system is doing and who it's actually communicating with. Now, I used -n, which just said show me the numbers rather than looking anything up. If I take the n out, it's actually going to do resolutions of host names. And this may take a second as it's trying to resolve everything. And now we've resolved everything. You can see that I've got a lot of names here to the different web servers. In this case, you can see HTTP, HTTPS. These are web servers that my system is communicating with. Just looking at an IP address isn't going to help you a ton. You really want the IP address, and so you probably want to do just a -a, which is going to give you everything, rather than doing the AN, which is just going to give you IP addresses. That could actually be faster and give you a sense of what's going on. If you want to know specifically where it's communicating to, drop the N and it will actually resolve the IP address for you. Netstat, route, ARP, all great network information utilities you can use to do some diagnostics as well as troubleshooting. So another set of good utilities for you to know. In this lesson, we're going to be talking about capturing packets. Now, this is a bit more advanced. It's a networking thing that you can do to actually see what's going on in your network. I would normally use like TCP dump. I could see what systems my system is communicating with, and I can see all of the traffic that's happening on my local network. You can see there's a lot of web traffic. I'm not really sure what that is because I don't actually have anything up that's communicating with the web that I'm aware of, which doesn't necessarily mean anything. There's a lot of stuff that goes on in the background. If I were to open up my browser here and go to google.com, I should certainly be able to see that as an example. So I can see all of my web traffic. Now, this is really difficult to read. I can read it. I've been doing this for a really long time. I understand what's happening here. If you don't know networking that well, this is going to be really difficult to see what's going on. So this is definitely one case where I highly recommend a graphical utility. And in this case, the best one that's around is Wireshark. Wireshark is not only probably one of the best network capture utilities out there, it also happens to be free. Now here I can go to capture interfaces, and then actually I need to be root when I'm doing this, so let me quit out of this and come back in as root. And then it's going to complain about some stuff because it doesn't like me running as root, but I can't actually capture from an interface without being root because that's just the way it is. So let me select that. It's a privileged process in order to actually start a packet capture on there. So let me do that. Now I have started the packet capture. Let me drag this window down a little bit here so we can actually see the list of packets. And now it's a lot clearer what's going on. Well, it's a little bit clearer. Now I've got a list here, but what I can do is I've got the packet broken up into all of the protocols that are actually being used here. And I can pop these open. I can see a lot of detail around the protocols and all of the different flags and data structures that are set within the packet. And I can see everything going on my network. I can see everything that passes across this particular network interface. Now, this is not something that I would expect a novice user to be able to just jump in and see and understand, but it's certainly interesting to run something like Wireshark, particularly if you want to understand networking better. There's no better way to learn than to actually look at the packets and what they're doing and how they're communicating with one another. And Wireshark is really a great way of breaking apart the packets into their component sections and seeing how they're actually put together. Reading books is great. Once you've read some books, you can really start using Wireshark and seeing how all of the networking stack comes together and how it communicates. So Wireshark, another great tool if you need to do network diagnostics. In this lesson, we're going to talk about the built-in firewall that comes with Linux, and that's called IPTables. Now, IPTables is the most recent version of a Linux firewall. It's actually been around for quite a while, but before this one, there was one that was called IPChains. Functioned similarly in terms of it was a firewall that came with Linux and worked inside the kernel or the operating system. Now I've got IPTables, and IPTables actually installs filters into the Linux kernel, and it's really a utility that you run and pass it a number of command line switches that will insert those filters into the kernel so that we can either drop or accept or manipulate packets as they're coming into and out of the system. So I'm going to show you the rules that are installed on my system now. And you can see there's actually nothing here. So I'm listing, and the -v is verbose, and I'm showing all of the rules on my system. You can see all I've got are 3 chains. I've got the input chain, the forward chain, and the output chain. And IPTables groups things into chains and tables, and I've got these chains that's really what I'm going to work with here. And the default policy is accept. So I can have a default policy of accept or a default policy of drop. In this case, I'm accepting everything that comes in. Now, if I actually wanted to add a rule, I would run IPTables, and I'm going to append a rule to the input chain, and I'm going to say the protocol is TCP, and I'm going to say my destination port is 80, and then I can say J, which means jump, and I'm going to jump to the accept rule. So what I'm really doing there is I'm accepting that. Now if I run IPTables -LV, you can see there's my accept rule. I could also add a drop rule. So let me do that. And let's just say the destination port here is 22. And I'm going to say J is drop. There are a lot of other things that I can do with IPTables. I'm just showing you some very simple, basic sorts of rules that you can add and make use of in IPTables. But I can do a lot of different things. IPTables gives me the ability to do network address translation, for example. I can do forwarding across multiple interfaces. There's a lot of things I can do with IPTables. You can see here's my drop rule, and it's to the SSH port, and I've still got my accept rule there. Now, I can also flush everything out of IPTables and just start from scratch as well. And let's see, I'm going to do IPTables -F, and we're going to flush the input chain. Now, if I do a -LV, now all of my rules that I input are gone, and I've flushed everything away. So that's just a very, very brief overview of IPTables to give you the idea that there is a firewall in Linux. There are things you can do with it. It does require a little knowledge and understanding of IPTables and the command line switches that you would need to install those rules. There are some GUIs that you can use to manage your IPTables, but again, this is all open source. It's not going to be the greatest interfaces like you would if you were to spend tens of thousands of dollars on a commercial firewall for your business. But IPTables really does work. It's really more a question of learning how to manage IPTables. That's really going to be where you're going to spend your time in terms of getting a firewall up and running on a Linux system. In this lesson, we're going to talk about doing remote communication across multiple systems. Now, I can log into a remote system if I've got, for example, SSH running. SSH is secure shell, and there's an older protocol called Telnet that would allow me to log into remote systems and get shell access or remote console access to those systems. Nowadays, we use SSH. The reason we use SSH is actually because it's encrypted. And let me actually pop open a new terminal here. Now, I've got SSH running at this point, and I should have an SSH server going. So what I can do here is I can SSH, and I'm going to just use localhost, which is just going to loop back, and I'm going to show you how you would use SSH. It's going to ask me about the fingerprint because I'm doing cryptography here, so there are keys that are being exchanged so that we can do encryption across the link. Now I'm going to log in with my password, and you can see that I am logged on to my local system. Not particularly impressive because it's just my local system, but the process is the same no matter whether I'm logging into another system on my network or whether I'm logging into a system somewhere halfway around the world. Process is exactly the same. In the case of what I did here, and let me drop out. In the case of what I did there is I logged into just the host name. I can also do a username. When I just specify the host name, it assumes my current username when I log in. So you'll see it's actually prompting me for the password of this user that I'm already logged in as. I could specify, and this user doesn't actually exist, so I'm not going to be able to finish this process. But if I specify Rick at localhost, it's going to prompt me for that password, and it will try to log me in as that user ID. I can get into systems remotely if they're running an SSH server. I'm going to get console access. I can pop graphical interfaces back. It's called X11 forwarding. That's a fairly advanced sort of thing to do. If you want to go do some configuration on your SSH server, you would go to SSH and then SSH_config. And here's the configuration file. You can see I've got forward X11 is no. I would have to turn that on. There are a number of other settings that I can use in terms of keys and identity files. There's a lot of different settings I can use for SSH and the SSH daemon or the SSH server. So that's how you might get into a system remotely just on a console basis using SSH. In this lesson, we're going to be talking about another useful networking utility. This is actually called Netcat, and I run it by typing NC. Now, Netcat is just going to open up a network connection, a TCP connection, to wherever I say. So I could do, for example, google.com, and I want to connect to it on port 80. And then I can just start typing. In this case, I'm typing HTTP into Netcat, and it's sending it off to Google. And I get a response back from Google, of course, because I just sent it an HTTP command. I can also use Netcat to communicate in a lot of different ways. So I could communicate with a mail server. I could communicate with any other network server that's out there. Or I could also use it to basically set up my own server to do some communication with. As an example, I could set up a listener, and I'm going to say on port, let's say 8000. Now I've got a listener here, and I'm actually going to pop open another terminal. Now I can use Netcat, and I'm going to connect to localhost port 8000. Anything I send just gets sent off to the other end. I could use this to transfer files, for example. I could do a lot of different things with Netcat. I can do troubleshooting, diagnostics. It's really pretty much a Swiss Army knife for networking. And as you can see, I did just a basic communication stream between two different windows here on my system. Again, I could do this across systems on the network, and it's pretty handy. I can get out of the way of maybe having a problem with a web server, and I could rule out, for example, my browser altogether by just going straight to, again, using Google as an example. I can go straight to the web server, communicate with it, see that I'm actually getting something back, and either rule in or rule out problems with my browser as a result. So it really does have a lot of uses, and Netcat is another one of those utilities that it's really helpful to have some understanding of and some facility with. In this lesson, we're going to start talking about some disk management and utilities that you would use for disk management. The first thing I want to talk about is managing the partitions on a hard drive. Now, a partition is a logical segment on a hard drive where you can actually store files once you've formatted that partition. Now, I've added a couple of hard drives to my virtual machine here so that we can play around with some disk things without corrupting the primary hard drive that I've got here. Now, under Linux, the devices are, again, referenced by /dev, which is how we get to the specific device. And then the primary hard drive is typically going to be SDA, and in this case, I'm going to be working with SDB. Now, what I want to do is I'm going to use the utility fdisk, and I'm running that against SDB, and I have to be administrator to do that. You can see it's giving me an indication that there's actually not a partition table, there's no disk label, there's nothing here. If I print, I'm going to see nothing. What I want to do is create a new primary partition. I'm going to say partition number is 1. The first sector I'm going to leave alone at 2048. And then I'm basically just going to create one partition that exists across the whole drive. Now I've got my partition. Let me actually write the changes out to the hard drive. And if I go back in here, print it out again, you see, first of all, I didn't get the warning about not having a partition table or disk label, and the partition is actually there. Now, in order to use this, I actually have to format it first. So I'm going to make an ext2 file system, and I'm going to add journaling, which is really going to make it an ext3 file system. I could also do an ext4 file system. So I could do makefs.ext4, for example, which is the most recent version of the ext family of file systems. which is the file system that's used by Linux systems, typically. So let's actually make an ext4 file system. So I'm going to use dev again, SDB, and SDB is the whole device. What I want is the first partition. So I'm going to make a file system that's an ext4 file system on /dev/sdb1, which is the first partition on the SDB hard drive. I've just created that file system, and now I could actually add that to my existing file system, and I could start writing files to it if that's what I wanted to do. In this lesson, we're going to take a look at a couple of utilities that you can use to manage and monitor the state of your hard drive and actually query it for some specific information. The first one I want to talk about is one called hdparm, which is used to get parameters for your hard disk. There are a lot of flags that I can use that I can get very specific information about the features on your hard drive. Like, for example, I can get the read-ahead setting, I can query the advanced power management settings, I can get 32-bit I/O support and see whether that's on, I can also set it. I can get and set a lot of different parameters for my hard drive. You can check the buffer cache, I can check the CD-DVD drive speed if I'm checking on a CD-DVD drive. Now, you can see as I'm flipping through the manual page here, there's just a lot of parameters that I can check here. And I'm actually going to just run this. So if I do hdparm, and I'm going to run it on my primary hard drive, which is SDA, you can see I've got I/O support for 32-bit I/O. I've got read-only is off, which means I can read-write. I can read ahead. And it gives me the geometry. So I've got cylinder head sector information, I've got total sectors, and then I've got start there. I can do a -v, which should give me basically a number of settings, and really it's no different than just running hdparm. I could do something like, for example, -m, and that gives me my multi-count. And again, there are a lot of different parameters that I can check with hdparm. It's helpful to query the hard drive sometimes. There is another utility that I can use, and that's smartctl. And that queries the smart status. Actually, let's look at the man page first. Queries the smart status of the hard drive. So SMART is self-monitoring analysis and reporting technology. It's built into a lot of hard drives, so basically you can query the disk for a lot of information about it. So let's run smartctl again about SDA, and let's do a -a on that. And now I've got a device model. It's actually giving me Ubuntu Linux -0 SSD. That's because I'm using a virtual machine. I would normally get something like Western Digital or Seagate or something like that. I've got a serial number, my firmware version. My capacity is about 68 gigabytes. I've got 512 bytes of a sector size. It's a solid state device. And I've got an ATA version and a SATA version. And it gives me a lot of information about the hard drive. It does say that the SMART support is unavailable for this particular disk. And again, that's because this is a virtual disk. It's not actually a physical hard drive. So I can't do some of the self-monitoring and analysis with this particular disk that I could with other disks that you may run across. But this is a couple of utilities that you can use to just query the status of your hard drive and get specific details about it. So for example, the capacity of the drive, you could get the device model and the serial number, that sort of thing. You can use these utilities to get information about your hard disk. In this lesson, we're going to be talking about RAID. RAID is a way of providing some better security and stability for data on your hard drives. It actually stands for Redundant Array of Inexpensive Disks, or you may also hear it referred to as Redundant Array of Independent Disks. What I can do with RAID is I can bind several different hard drives together to create either one larger drive or I might be able to protect the data that I've got by using what we call mirroring, where the same data is written to two separate hard drives. So what I'm going to create here is a mirrored RAID set. I'm going to use a utility called mdadm, and I had to install this. It didn't actually come installed by default on my Ubuntu system. So I'm going to create /dev/md0. I'm going to say level equals 0, which is my mirrored level. And I'm going to say RAID devices equals 2. And then I'm going to specify my RAID devices. So I've got SDB1 and dev SDC1. This actually should create my RAID device for me. And it noticed that I had actually put a file system onto SDB1. I don't really care about that, so I'm just going to say continue creating. And now I've actually got dev md0. And at this point, I could actually create my file system here, ext4/dev/md0. And now I've got a file system written out to my device. I could actually mount this up and start writing data to it. Now, you remember I'd mentioned a mirrored set. What I've done here is I've created a mirrored set by using two separate partitions. I've used SDB1 and SDC1, and those are the separate partitions on two different hard drives. And what I've done with those is I've said any data that gets written out to the disk that is created from this RAID process is going to get written out to both of these separate partitions. So one is going to mirror the other. What happens in that case is if one of the devices actually fails, I've still got the data on the other device. Now, there's a number of different RAID levels. This happens to be one of the basic ones, but using mdadm, you can use any of the RAID levels, and you can create RAID devices from a much larger number of disks and partitions if you happen to have them around. In this lesson, we're going to be talking about logical volume management. In a way, it's kind of similar to RAID. And the way that it's similar is because I can bind a number of disks together to create one large logical volume. Now, there are a number of tools that I would use to create that. And I could use pvcreate to create a physical volume. And then I would create a logical volume using lvcreate. And then I would create a volume group. So I have to do all of those things. Now, fortunately, I've actually got a logical volume that's set up here because I set it up when I installed the system. And I can run lvscan. I've got my Ubuntu-VG for my volume group. And out of that volume group, I've actually got two separate partitions that I've created. So once I've created this big volume group that could be composed of multiple hard drives, I can carve it up into several different partitions. So I've got my one root partition here, and then I've got a swap partition that's been created there as well. So there are a number of settings and parameters that I can set when I do these logical volumes. There are a number of utilities that I can use as well. So I could use lvextend to extend the partition. I could do an lvdisplay. And that's going to ask me, first of all, to be an administrator. And that's going to display the two logical volumes that I've created out of my volume group. So I've got the root logical volume, and then I've got the swap logical volume that comes out of the Ubuntu-VG volume group. You can see the size here is 62.76, and then I've got a 1 gig logical volume for my swap partition. So logical volumes are a way of kind of gathering a lot of disks together and then being able to carve out partitions from them. In this case, it's really just one disk, but having this logical volume gives me the ability to add additional disks into it and just increase my space without having to, for example, copy everything here onto a larger hard drive. All I've got to do is add another hard drive into the system. I add it into my volume group, and suddenly I've just got that much more disk space that's available. In this lesson, we're going to be talking about formatting. Once I've created a partition or a volume, in order to actually write data to it, I have to have what we call a file system on it. And the file system provides, first of all, organization for the data, as well as a way of storing information about all of the data that we're storing there. So, for example, I've got a file here. Let's just take a look at my file, for example. Now, my file is the data that's inside the file, which is really what I care about, but there's also the file name and a lot of other information about the file that needs to be stored. And for example, we've got the owner and the group, and we've got access times and dates and permissions and those sorts of things. So we've got to have a place to store all of that information, and the file system is what makes all of that possible. Now, with Linux, I've got several different file systems that I can actually create. So I did an MKFS, and what I use typically when I'm doing a command line is I use what we call tab complete. So I did MKFS and then dot, and then I hit tab twice. That brings up the list of all of the possible completions that I've got here. The reason I did that was because I know that's going to give me the different file systems that I can create. Now I can create the different ext file systems. So I've got ext2, I've got ext3, I've got ext4. I've also got the older Minix file system, which is where Linux comes from, actually. It comes from an educational distribution called Minix. I've also got the various Microsoft file systems, so MS-DOS, NTFS, and VFAT. I've also got a compressed file system that's called CramFS, and BFS is another file system that I could use. So these are the ones that actually come installed by default. I can use any one of these to install to my partition. All I have to do is say MKFS, let's say MS-DOS, and we'll put that onto, this is still the RAID device that I had created earlier. Now that the file system's created, I can start writing files to it. In this lesson, we're going to be talking about mounting partitions into the file system. Now, under Windows, this is something that you don't generally have to worry about when you install a hard drive or add a partition or insert a CD-ROM, any of those things. Windows actually effectively mounts the drive itself. It may prompt you for a drive letter so that you can more easily refer to that drive. Now, under Linux, we do something a little bit different. And the same thing with Unix. Again, Linux inherits all of this type of behavior from Unix. Under Unix, you have a single file system. Everything exists under the root directory. So we have /, which is the root directory, and everything exists under there. If I were to add another partition, another hard drive, some removable media or whatever, it would get mounted somewhere under the root partition. Now, typically, you might find it under, say, for example, /mnt, or it may be under /media. Some of this depends on the specific distribution or implementation of Linux that you're using. There also sometimes is, for example, a /mount directory. In this case, that's not existent on this particular operating system. So Ubuntu doesn't use /mount. They do have a /mnt and they have a /media. Now I can see all of the partitions that are mounted just by typing mount. You can see we've got this device here, dev mapper Ubuntu volume group is mounted on /, and there are the pseudo file systems, proc, sysfs, and so forth. And then we've also got /dev/sda1 is on /boot, and that's type ext2. So we can find all of that information. Now, if I actually want to mount something myself, then I would first of all have to be an administrator. So I'm going to run sudo, and I'm going to mount /dev/md0. And this is the RAID device that we were using previously. And I'm going to have to specify a place in the file system I'm going to mount this to. This has to be a directory, but it doesn't actually have to be an empty directory. That gets a little confusing. I can actually mount this to an existing directory that has content in it, and what I'm really doing is I'm replacing that with the position of this media device that I'm actually mounting to. But we're not going to worry about that right now. If I unmount that, all of the original files and directories come back. It's not like they've been overwritten or anything. It's just that we've basically inserted a link into the file system to get to this new location. Now, again, I'm not going to worry about mounting up to a directory that already exists. I'm just going to mount to an empty directory. And as we saw previously, /mnt exists and it's empty. Now I've actually mounted the hard drive, that RAID device that we had created previously, and I mounted it to /mount. So I can ls/mnt, and of course I get nothing there. I could, however, let's copy some things over, errors to /mnt, and now if I list /mnt, I get errors.txt. I can unmount that same device, and I'm going to say umount for unmount /mnt. Now I've unmounted it. If I just do an ls/mnt, of course nothing's there anymore until I remount it. And now if I do a listing of /mnt, of course what I wrote out there still exists because it's written out to this hard drive, and it doesn't matter whether it's mounted or unmounted, the data is still out on the device. So that's how I would go about mounting additional entries into my file system so I can add additional hard drives or partitions, removable media, and so forth. In this lesson, we're going to be talking about other file systems. Now, I had looked at this very briefly earlier when I was talking about formatting. So let's just take a look at makefs and the different file systems that I can use. Again, we've got the ext family of file systems here. We've got ext2, ext3, ext4, and those are the file systems that are traditionally associated with Linux. They were developed to be part of Linux, even though there are other file systems that can be used. These were the file systems that were developed specifically for Linux. Again, we've got the Minix file system, and that is really a precursor to the ext file system family. Of course, we've got MS-DOS, and I could actually create an MS-DOS device. Again, I'm going to have to be root to do that. Now, you may see me bouncing back and forth between the beginning and the end of the line. I can actually do command line editing here. So a Control-A brings me to the beginning of the line, and Control-E brings me to the end of the line. So I can bounce around pretty easily. Now, I'm going to use that RAID device that we were talking about before. And then I can actually mount that just as we were doing previously. Now, if I run mount, you can see at the very bottom that we've mounted /dev/md0 on /mount, and it shows up as type vfat. The reason it shows up as type vfat is because the MS-DOS format command, the mkfs.msdos, actually creates a bigger FAT32 volume. It's not using like the older FAT12. It's using a more recent FAT version, and so it shows up as vfat. It's still something that can be used pretty easily on any Windows system. I could put in a removable device like a thumb drive, USB stick, external hard drive, anything like that. I could format it using mkfs.msdos, write data to it, and then, of course, I could unmount it, bring it over to a Windows system, and it would all work just fine. So I can use a lot of different file systems. And again, let me just copy some data over there. And I'm going to use the errors.txt again. First of all, let me show you that when I formatted, everything went away. Not surprisingly. So let's say errors again, .txt, and we're going to copy that to /mnt. And then we're going to copy my file, and I'm going to copy everything that looks like my file. So I'm going to put the asterisk on there, and then we're going to copy that over to /mount, and I need to be root because I don't actually own that device there. So /mnt. And again, I have just written out to a VFAT formatted or just a standard MS-DOS FAT file system, and I've done that under Linux. There are a number of other file systems that I can use, even above what we've got here. Typically, I can use a lot of Unix-like file systems, so JFS, RicerFS, and XFS are some different file systems that I could actually use under Linux if I were to install the support for them. But by default, what we've got here is support for the various Windows-based file systems and, of course, the Linux file systems as well. And those are the ones that you're commonly going to use under Linux. In this lesson, we're going to talk about using removable media. Now, by removable media, I'm talking about a USB stick, thumb drive, or CD-ROM, or anything that I can add and quickly remove to my system. Now, in this case, I'm going to plug a USB drive into a thumb drive into my system here. And because I'm running this in a virtual machine, it's actually going to ask me whether I want to connect to my primary operating system, my host operating system, or the guest operating system. And I'm going to add it to my guest operating system here. And then we're going to see what Linux does with a removable device. Now, you'll see that it immediately pops up a file explorer window with that device mounted. And if you noticed, when I plugged it in and it was asking me what I wanted to do with it, and I added it to the virtual machine that was running Linux, it did say USB 20FD. And again, I can do the same sorts of things here as I can with any other file explorer that you're used to seeing. I can just drag and drop over there. But you can see that it automatically mounted it, and let's actually take a look at where it mounted it. You can see here that it's got /dev/sdd1 as its device name, and it automatically mounted it to /media/Kilroy, which is my username, /USB20FD. It's type VFAT, and then here are all of the options, and that's something we didn't talk about when we were talking about mounting. I could mount read-write, I can mount read-only. There's the set user ID, no device UID, GID, so forth. So I can specify a lot of options when I am doing mounting. Typically, though, I'm not going to specify any options if I'm doing the mounting, but I certainly could. Now, when the system mounts, this is how it mounts, and it's actually mounted for my user ID, and because it mounted as my user ID, I can easily write to it. And I'm actually going to delete this and move it off to the trash. So you can see that it automatically mounted, and it immediately brought up a File Explorer window for me, very handy. And now when I'm ready and I've done everything I want to do with it, so reading, writing, and so forth, I can just eject it. And then I can pull it out, and I'm done with it. I can go do whatever I want with the device. But any removable device or removable media is going to behave in this way. And as I said, what you saw was my virtual machine software catching it first and saying, what do you want to do with this? If you were just running a straight Linux system, you wouldn't see that. You would just see Linux automatically mounting it, and it would present it to you for your use for reading and writing and so forth. In this lesson, we're going to start pulling some of the things that we've been talking about together to actually do something useful or with a very specific purpose. So we're going to install a web server, and then I'm going to install the WordPress blogging software or content management system. Now, the first thing I need to do is I need to figure out what packages I need to install. So I'm going to look for Apache 2, so that I can get the actual package name that I'm looking for. And you can see there's a lot of lib Apaches there. And I actually am calling it Apache 2 because there was an Apache server, but we're currently on version 2. I happen to know that. So that's actually what I'm looking for. Looks like the name is Apache 2. So I'm going to remember that. And then I'm going to look for MySQL. So the MySQL is the database server that I'm going to put behind WordPress when I get around to installing that. And I need to find, actually, let me do a little grep here for server, so I can find the specific server that I'm looking for. there are a lot of different packages that make use of MySQL. It's going to show up when we do the search, but I wanted to narrow that. So what I'm going to do here is I'm going to apt-get install, and then I'm going to say MySQL-server Apache 2, and then I want PHP, which is a programming language that was specifically designed for building websites. And so I'm going to actually use PHP here. And it's looking for PHP 5. There isn't a package named PHP. And that's probably why I should have done a search. I thought it was probably going to need a version number, but I just tried it without. Of course, it didn't show up. So now we're going to go install the packages. You'll see there's a lot of other packages here that it has decided to add, and that's because those are dependencies for the things that I want to do here. Now, this is going to take several minutes to download everything and get it installed, but this is really the starting point for getting to the point where we can actually get a web server up and running and start serving content. And then after that, we'll install the WordPress content management system, and we'll actually be able to set up a little blog site here. At this point, I'm done installing the MySQL server. We've got Apache installed, and I've actually installed PHP as well. So in this lesson, we're going to talk about configuring Apache. Now, fortunately, there's not an awful lot that needs to be done to configure Apache. Let me show you where the Apache configuration files are. Not surprisingly, by this point, you should recognize that they're going to be in etc. And under etc, it's going to be in the directory Apache 2. Apache 2 has the apache2.config file, and let me just take a quick look at that. This is the primary configuration file, but it's not the only configuration file, and I'll show you where the others are as well. It's pretty well documented, and you can see the different configuration settings here have definitions for what they are and how you might set them. In this case, I'm just going to leave all of that alone. We've got the process ID file, there's a timeout, keep alive, and so on and so forth. We've also got a user and group setting and the different log levels that we can use. Now, I'm going to leave this file alone, and I'm actually going to go take a look at another file. We're going to go into sites-enabled, and let me do an ipconfig, and actually I want to do an ifconfig, not on Windows, and I want the IP address. And I'll show you in a second why I want that IP address. Now, let's edit the 000-default.conf. And here's where we would actually go set the server name. And I'm actually going to set it outside there. So we've got a global name for the server. If I don't set the server name, we're going to get errors, not that they're going to be critical errors or anything like that, but it's going to tell me that it has a hard time figuring out who it actually is, and I should go set the server name. So I'm going to set the server name there, and let me write that out. Now, once I've done that, I'm going to actually use the Apache 2CTL utility to restart the Apache server. At this point, I should be able to get to the default page if I go to 10.0.0.28, which is my local IP address. And sure enough, I get it works. This is the default web page for this server. Web server software is running, no content's been added. This is the default index page that gets installed by Apache when we install the Apache configuration. You also notice that we didn't get any errors. If I were to leave that line out, and let me comment that out, and you can see specifically the error that we get. Let me restart. You'll see that it couldn't reliably determine the server's fully qualified domain name, and I should set the server name directive globally. So let me go back to actually doing that, and then I can restart again. We drop the error, everything is happy, and we can go on our merry way. In this lesson, we're going to talk about modules inside of Apache. Apache has a base executable that does the primary job of actually serving up web content. But there are a lot of other features and functions that it actually needs to do some important things. And one of those important things is supporting the PHP language that we're going to need for WordPress. I'm going to go into the mods enabled, and that's the modules, and we're going to take a look here at the different modules that we can actually load up. These are the ones that are enabled, and let's just take a look at the ones that are installed. And we've got a lot of them that are actually available, but just this set here is what's actually enabled. What I'm looking for is the PHP configuration and the PHP load. So we're going to take a look at that configuration. And I want to make sure that Apache is configured to handle PHP files. You can see that if we find something that looks like PHP, and this is a regular expression, and I haven't really talked that much about regular expressions. They can be really complicated, and certainly they can be difficult to read quickly if you're not used to them. They may be a little frightening with all of the different special characters in them, but what we're looking at here is if we find a file that matches something that looks like .php or .php3, 4, or 5, or it's got like .phtml, something like that, we're going to set the handler so that it gets handled by this particular MIME type here, which is application/xhttpd-php. And once we've set that MIME type, then we'll actually take a look at another configuration file in a second. That MIME type we're going to configure to be handled by the PHP module. So let's take a look at that actual config file right now, php5.load. And you can see we're loading up the module php5 module, and this actually tells it where it is. And so once we have seen that it's a phpd PHP file, then it's going to be handled by this module. So now we've got PHP configured so that anything that we install inside of our web server that has PHP files can actually be handled by the PHP interpreter, and they won't just show up as plain text. They're actually going to be executed as programs, which is effectively what they are. In this lesson, we're going to take another look at Samba. Now, Samba is the Linux package for providing server message block functionality. Server message block is the protocol that Windows uses to share files amongst the systems on a Windows network. Let me just make myself root here so I don't have to worry about permissions problems. So now I'm going to go into etc Samba, and we're going to take a look at what's here. The first thing is we've got the smb.conf. And I know we've taken a look at this previously, but what I'm going to do is I'm going to set up a share here so I can get to the files in my web server from other systems. So I can do any page editing somewhere else, and then I can just copy them over. Now I'm just skimming through all of the configuration before we get to the shares. Everything is fine by default. As a general rule, the file serving is going to work just fine. What I do need to do, though, is I need to actually configure a share so that we can get to the right directory. Now, let me install a share here. So I'm going to give it a share name, and I'm just going to call it web. This is the name it's going to show up as when we go browsing the network. I'm going to say comment equals web root file share. Path is going to be equal to /var/www, which is where I know that that lives. And I'm going to say read only equals no. And that's really all I need to do. I can now restart Samba, and that file share is actually going to show up on the network so that I can start copying files to and from it. If I wanted to do my page creation somewhere else, I can actually just store the files off onto this file share on my local network. Of course, I can also create them locally, and then I would have permissions things to deal with. And let's just take a look at the permissions for /var/www. And sure enough, it's all owned by root. If I actually wanted to do the page creation myself, I would have to change the ownership. So I would have to change owner to me on /var/www. Of course, I'm going to have to do that as root because that is who owns the file. So I could actually do that, and let's take a look again. And you can see that I now own that directory. Of course, I don't own the file in it. Had I done this instead, so a recursive cho, now I would own everything in that directory, and I would be able to make changes to the index file. For example, I could now add files to that directory and so forth. In this lesson, we're going to talk about installing WordPress. Now, I could certainly go off to, let's say, www.wordpress, and that's going to take me there. I could download WordPress if that's what I wanted to do. Then I would have to go unpack it, put it into place, and do a lot of work myself. What I can do instead, though, is I can just search for WordPress within my package list. And sure enough, I have WordPress, which is a weblog manager, and we can see that right there. So now I'm going to do apt-get install WordPress, and it's going to go install the various packages that we need. Like we've got JavaScript Common, and we've got some other libraries. We've got a couple of additional PHP packages that we haven't installed, and it's going to go install those automatically for me. You'll see that there are a handful of other packages that somehow make reference to WordPress, and we've got a couple of weblog clients. So we've got a blogging client called Drivel. There's a Unity web app for WordPress, and we could actually manage our WordPress installation that way. So there's a number of things that we could actually install. Right now, though, I just want to deal with getting the server up and running. So I'm going to say yes, and it's going to go grab all of the packages that it needs, and it's going to automatically install all of those packages for me, which doesn't mean it's going to go do all of the configuration for me. It's still going to leave the WordPress files in place so that I can finish doing the configuration myself, which means I'm going to have to somehow let the web server know, my Apache server, that I've got this set of files that doesn't actually live under the web root, and I'm going to have to make all of that work. It's not very difficult, but it is something that we're going to have to do. As I said, it doesn't install all of that automatically, so we're going to deal with that coming up once all of this is installed. In this lesson, we're going to actually go do the final configuration that we need in order to get WordPress in place. What I'm going to do is, first of all, let's take a look at /var/www. There's actually nothing there that has anything at all to do with WordPress. The reason for that is because when we do the installation, the WordPress files actually get loaded into user share WordPress. Now, what I need to do is I need to get everything in user share WordPress over into var www. Now, what I could do is cp-rf/user/share/WordPress into /var/www. Now, what it's going to do is it's going to put everything in this directory, including all of the directories underneath it, and it's going to put it into var www. Now, there's a problem with doing that. The problem with doing that is that if I ever upgrade WordPress, then I'm not actually going to pick up the upgrades unless I do a copy of all of those files into var www again, in which case I run the risk of overwriting some things that have changed since I actually did the installation. Now, what I'm going to do instead is I'm going to create a symbolic link for /user/share/WordPress, and I'm going to put it in /var/www/WordPress. Now, what I've got is, let's take a look at /var/www. I've got a directory called WordPress, and it actually refers to all of the files that are here. Now, when I do an upgrade on WordPress, it's going to upgrade all of those files in a safe way, and I'm automatically going to pick those up because this directory right here is really just a symbolic link to where the real files actually live, and I can leave those where they are and not have to worry about them. Of course, one of the reasons that they're installed into user share WordPress is because I may actually want to have multiple configurations of WordPress if I've got multiple virtual hosts. So I could have several different blogs if I wanted to. And so they don't just automatically install WordPress into the root of your Apache document directory and expect you're just going to use it. They put it off somewhere, and now it's up to you to figure out how you're going to use it and install it the rest of the way in a way that makes the most sense to you. Now, we're also going to need to deal with the WordPress configuration. There's going to need to be a configuration file that we actually put into place that specifies database and so forth, and we'll deal with that shortly. We're going to have to do some database creation and then do a very, very simple install once we've got everything configured on the server side with the database and connecting everything. Actually doing the installation of WordPress once we've got the database installed is really, really easy, and I'll show you how that works. We'll do that coming up in the next couple of lessons. In this lesson, we're going to go create a database inside of MySQL. I'm going to run the MySQL client in order to do that, and I actually had to install the MySQL client. It doesn't get installed by default when you install the MySQL server. It's one of those things where I have a server, I may not want the client there because I may be doing the management of the database in some other way. We don't install packages that we don't have to install, so we didn't install the MySQL client, and I actually had to go do that. Now it's in place. I need root permissions because I'm trying to get in as an administrative user in MySQL, and I have added the -p saying prompt me for a password, so I'm going to log into the MySQL server now using the MySQL client. Now I'm logged in, and we're going to just show the databases that are already installed here. And we've got information schema, MySQL, performance schema, and test. Now I don't have a WordPress database that's set up here, so nothing up my sleeves. Let me create the database. And I know this sounds really impressive. It's actually not. Create database, WordPress. And we've just created a database WordPress. If I show my databases again, of course, I'm going to see WordPress there. Now, I don't actually have any data associated with it. There's no tables, there's no schema, there's nothing there. It's really just an entry in the system database saying there's a database that's named WordPress. At some point, there will be some other stuff associated with it, but right now, all we've done is carve out a space with a name saying there's going to be a database called WordPress, and that's all we need to do at this point. In this lesson, we're actually going to add a user to the database server so that WordPress can access the database that we've created. I'm going to get back into the MySQL monitor or MySQL monitor. I'm going to log in here. Now, I've got my database, and we'll just take a look here again, show databases. We've got the WordPress database. Now, I've actually got 2 steps to complete here, or 2 tasks to complete, and they're actually going to get done in the same step. In addition to creating a user, I have actually got to grant permissions to that user to the WordPress database. Now I'm going to grant all permissions, so grant all on WordPress. Asterisk means all tables in the WordPress database. 2, we're going to say WordPress at localhost. And that means that the only place that I can log into this database from with this user is my local host, which means I can only get to the MySQL database from this system. I can't access it from the network, even if my MySQL database was exposed to the network and I was listening on the network. I couldn't actually log in from the network with these settings here. So WordPress at localhost, identified by my password is going to be WordPress. And I've got to close it with a semicolon. And now we've got the user WordPress that has been added to the database. And we'll just take a look here. Use MySQL, which is where all of the users are stored. And if I do a select asterisk from user, now right here you can see we've got the WordPress user and we've got the hashed password. I've created the user, and now what we can do, now that I've got the user and it's only capable of logging in locally, which is all we're going to need from WordPress because it's going to be the web server that is logging in, or the program that's running inside the web server that's actually going to be logging into the database. So we're going to be good there. Now, the next thing we need to do is we need to configure WordPress so that it knows what the login information to store all of the content in the database is. At this point, we've created a database and we've created a database user. Now, in order to go forward, we need to tell WordPress all about all of that information. So in this lesson, we're going to configure WordPress. For example, if I were to just go to my web browser, go to wordpress.org, download the source code, and just install it myself, I would be configuring within the directory where WordPress is. With Ubuntu, actually what we do is we open the door to the possibility of having multiple installations of WordPress if I am hosting virtual servers. So maybe I've got multiple web instances of WordPress because I've got multiple blogs that I want to support. In that case, we've got Etsy WordPress, which is the directory where the configuration files are stored. Now I have to have a configuration for each instance of WordPress that I am trying to support here. In this case, I've created already a config file, and that config file is config-10.0.0.28.php. So the convention is config- and then either host name, or in this case, we've got an IP address because I don't have a host name, and that's going to be my configuration file. So when I try to go to the WordPress URL in my browser, it's going to look up the correct configuration based on how I go to that actual URL. And let me just take a look here at the config file. We'll show you what's going on. I've created a little PHP script, basically. That's what this is. And this file is going to get included when we actually run the PHP for WordPress. So every page that we go to is going to include this little section so that the PHP scripts know how to connect to the database. You can see we've actually added a DB name, which is WordPress, which is what we created, and then a DB user, which is WordPress, and we created that user. There's the password that we used. And then the host, of course, is localhost, and I've actually specified my content directory as /var/www/WordPress, which is where we created the symlink from user share WordPress. I've got all of my content here into var www/WordPress. So all we need to do now is finish the configuration using the web interface. In this lesson, we're going to finish off the WordPress installation, and I'm going to do that using a web browser. So I've brought up Firefox, and I'm going to browse to my WordPress directory here, or WordPress URL. So we're going to go to 10.0.0.28, which is my local system, /WordPress, which is, of course, where we put the WordPress installation. Now, in the background, you can see I've actually got the logs running. I'm just taking a look at the /var/log/Apache2 access log, and let me just show you what I did here. Doing a sudo tail -f, which is going to show me the tail, or the last part of this particular file, and it's going to keep showing me every time something new pops up in the log. That's the -f. So it's not just going to show it once, it's going to keep looking, and as I add more to that access log, it's going to keep showing. So right here we've got the configuration, and I'm going to give it a site title, my WordPress Nothing particularly interesting. Admin. And the password, I'm going to give it a strong password here. And then my email, I'm just going to say is root at localhost. And I'm not actually going to allow search engines to index the site, first of all, because it can't get to it. And also, this is just a test system, so I don't really need the search engines populating with this content. Now I'm going to click Install WordPress. It's going to ask me to remember the password, and let's just add that in. Now I'm going to install WordPress. I'm not going to bother remembering the password. And now we've installed WordPress. And actually, let me quit out of this and we'll take a look at MySQL here. And we're going to use WordPress, which is our database. Now I'm going to show the tables. Now you can see all of the tables have been populated in the database, and the installer here has actually taken care of that. Let me actually log in here. Admin. And I'm just going to check remember me. Yeah, this time I'll remember the password. Now, of course, we could customize the site. We could add themes and so forth. This is the theme that's there. I could select something else if I wanted. I would probably have to go download some other themes. There are only so many that actually get configured when you install it, but certainly there are tons of themes, and you can change the appearance with different themes. Here's the available themes. Currently there's only one, so I could customize the theme by making changes to it and so on and so forth. So you could leave it alone, you could install themes, you could install widgets, lots of different things you can do once you've got WordPress installed, but the real core of it is this is how you would install WordPress on an Ubuntu system using a typical LAMP infrastructure with Linux, Apache, MySQL, and PHP. In this lesson, we're going to talk about actually using HTML editors on the Linux system itself. First thing I want to do is actually install an HTML editor. This happens to be one that I know. It's called Bluefish. Works pretty well, and we're going to install Bluefish, and once I've installed it, I'm going to go and just double check that I've got permissions to actually make changes to the content here. It's finishing installation, so we should be good in just a second. Now I'm going to do ls-la, which is going to give me a long listing, and I can see that I am the owner of the directory. Remember, dot is the current directory. And I'm also the owner of index.html. That's great. Now what I'm going to do is I'm going to run Bluefish against HTML, and I'm going to send it to the background as we've talked about previously. And I've got my HTML editor up now, and I can make changes. Let's just change this header to my silly page. And that's the default, is no longer the default page. And I have added content. Now, let's go grab an image here. Let's go to Infinite Skills, and we'll find an image there. I'm going to save image as. That's fine. We're going to save it into downloads. Now all I need to do is copy, and remember Wiggle is my home directory, downloads, and asterisk.png to my local directory there. So now I've got web-logo.png, and I can go back to Bluefish, which is over here. Up top, I'm going to insert an image. Now I could use one of the buttons up here, for example. Like I could insert an image right here, and I could say web-logo.png. Let me add some alternate text here. Say logo. And now let's just save this. I'm going to save my current file. Now let's come back here and say 10.0.0.28, and our new page should pop up. And sure enough, there it is. So I've added some content. I've used my HTML editor to do that. and we've inserted an image and changed some of the text from the default index page that was there. So easy to edit content right on the Linux system. Again, there are some pretty good editors. Bluefish happens to be a pretty good HTML editor if you're familiar with code. If you're not familiar with editing HTML itself, there are other editors that are available. You can certainly go looking for other editors that are around that would work under Linux. In this lesson, we're going to talk about bash scripting. Now, bash is the born-again shell, and it's actually the command interpreter that we're sitting in front of here, so any command that I type gets handled by bash. Bash has a lot of programming constructs, so it's not only a shell, it's also basically a programming language. I can write scripts in bash. For example, here's the bash profile, so every time I log in, this little script actually runs. You can see there are a lot of programming constructs here. We've got if statements, we're checking values, we're setting variables, all sorts of programming things. So what I want to do here is I'm going to walk through over the next several lessons some of the different scripting languages that are available for Ubuntu. Some of them are installed by default. Bash happens to be one of those. So I'm going to vi test script.shell. And at the very top here, this is called a shebang. The pound exclamation point there is a shebang. And then we're saying bin shell is going to be the interpreter that handles this. So the first thing I want to do is I'm going to check if a particular file exists. I'm going to say test script.sh. And this is my little test box here. So we're going to check the value of this, and -f says, is that a file? Is what comes after that actually a file? Then echo found the file. And then I'm going to end my if statement with an fi, so it's just the reverse. Now I'm going to set a couple of values here. S equals 2. And now I'm going to do a similar sort of thing where I'm going to test whether this equals this or not. So to the variables t and s, are they equal? If they are equal, I'm going to say echo they are equal, else echo they are not equal. Then I'm going to end the if statement, and finally I'm just going to say the classic hello world. Now, what I can do here is I can make this executable by changing the flags on it. So I can change the mode here, and I could say +x, which means add the executable bit to test script.sh. Then all I have to do is say test script.sh, and I've got to refer to it with the / indicating it's in my local path, because if I take a look at the path, dot is not in my local path, so I can't do test script.sh because it says it's not found. If I do this though and tell it specifically where it is, that's actually going to run. Now I've got a script that's going to run. If I didn't set the executable bit on the script or on the file, I could have done this. And in that case, I didn't have to reference the / because I was actually passing the file name to the shell, or sh, which is the command interpreter there. Now, that's how you would very simply create a shell script. Again, there's tons of things you can do with a bash shell script. I've just created some very simple functions inside the shell script that we were looking at. And we'll do kind of the same thing with other programming languages coming up in the next few lessons. In this lesson, we're going to take a look at writing the same script, but we're going to write it in the Perl programming language. Perl, actually spelled P-E-R-L, has been around for about 20 years or so at this point. It works really well as a scripting language, does a lot of really nice things. There are a lot of modules that are available for it, which makes programming complicated functions a lot easier because other people have done the work for you. So I'm going to take a look at a Perl script that I've already got in place. I'm telling my command interpreter that Perl is actually the interpreter for the rest of this. So we're going to use Perl, and you can see The first thing is I'm testing the existence, so that's the -e, of testscript.pl. And one thing you'll notice here is I actually have curly brackets around the thing that I'm going to execute. So this is a block of code. If testscript.pl exists, then we're going to execute everything inside these curly braces. Now, underneath that, I set a couple of variables, and I do $t equals 1, $s equals 2, and then I check if $t equals is an equivalency operator. And that's to differentiate from the single equal sign here, which assigns values. We don't want to assign a value inside the if statement, so we just want to check equivalency, and that's why I use the equals. Again, if $t equals s, or equals s, then I'm going to print they are equal, else I'm going to print they are not equal, and finally I'm going to just print hello world. And you'll see I've got a \n at the end of each print line. That's a new line character. And the new line character is basically a carriage return line feed. And so we drop a line and go to the beginning of the line in order to not run everything onto the same line. So let me just quit out of that. And I've already set the executable bit on test script. You can see the X here in my directory listing. So I've got read, write, execute, and just execute and read for the group and the world, or everyone. Now all I have to do is say /testscript.pl. We found the file, the two things are not equal, and hello world. So we've got a Perl script here. Let me just pop it back up again for you. Again, a very simple Perl script. We've just done some if-then sorts of things, and we've done some setting of variables and then checking whether those variables are equal, a little bit of printing. So nothing particularly fancy, but that's how you would do Perl scripting, using Perl and creating a little Perl script file, and then you would just run it by setting the executable bit. In this lesson, we're going to recreate the functionality from the script that we've been writing so far, and this time we're actually going to do it in Python. And .py is the file extension typically for Python files. Going to add shebang user bin Python. And the first thing I need to do is I need to import some functionality. This is a module that exists in Python, and it's going to help me write this program a little bit more easily. So I'm going to say if os.path.isFile testscript.py print file exists. I'm just going to throw in an else there. Print did not find the file. Now, you'll notice I didn't create any blocks, and I didn't actually end the if statement. The reason for that is Python is very dependent on white space. So when I inserted the tab before the print, it indicated that's a block that exists underneath the if. And you'll see the colon actually is basically the delimiter for the if statement, and I've got a colon after the else as well. Now I'm going to add the remainder of the program in, t equals 1, s equals 2, and then if t equals s, colon, and again I got a tab in. Now I've been tabbing for the other languages, and that's just because it makes it easier to read. Python takes that concept of easy to read and actually enforces it, and that's how you create blocks underneath where you are. Else print they are not equal. And then finally I'm going to say print hello world. And now chmod plus x testscript.py, and I should be able to testscript.py now. And I actually added an additional dot that I didn't mean to put in there. File exists, they are not equal, hello world. So we've got a script that actually works. And you can see when I actually generate an error, it tells me the line that it's on and then points out very specifically where the error is. And that's just because I typoed and put a dot in there where I didn't actually mean to put a dot in. But that's Python and creating the same script within Python. And you can see some of the differences between Python and Perl, for example, and also with Bash, the scripting language, which is just part of the command interpreter. In this lesson, we're actually going to do the same script, maybe getting a little tiresome by now, but you can compare more easily if we are doing the same functionality across all of the scripts. And in this case, I'm going to use Ruby. And Ruby's even more different than the others. Ruby's actually very clearly an object-oriented programming language. And the reason I say that is because it behaves differently than the others, and I'll show you why in just a second here. testscript.rb.file ? We're getting the status of this file here and then calling whether that's actually a file based on the status. And that's very different. You'll see the question mark because it's a Boolean operator. So the question mark makes it very clear that you're checking basically a true or false. Now in this case, I'm going to say print, found the file. And again, I need to add in the \n for the new line. Else, print did not find the file. And then I'm going to end the if statement. Now I'm going to say t equals 1, s equals 2. And this is going to be a little bit different. I'm going to say put string are t and s equal. And now I'm going to get the value from t equals s, and I'm going to print that value. So I'm checking to see whether something is true or false. And then I am actually going to print, actually let me get rid of these spaces and make it a little bit cleaner. I'm going to print the true or false statement that results from that. So Ruby is actually going to print true or false based on whether that statement t equal s. And finally I'm going to say print hello world. And again I'm going to put my \n in there. Now I can just run the script, so /testscript.rb. Found the file rt and s equal false, because they were not, and then finally hello world. So again, you can see, let me print this out, .rb, and let's just take a look at testscript.py, for example. So you can see the two on the same screen. We've got Ruby where we're doing a file stat and then asking if it's a file, again the question mark. And down here we're making use of a module inside of Python, or that we're importing into Python, and we're saying os.path.isFile, and then passing it in a file name. So the syntax is a little bit different. Ruby's a bit of a different mindset in terms of how it works and the way you can do things. But Ruby's another really good programming language, a good scripting language that you can make use of to do some really cool and interesting things on your Linux system. And frankly, all of these programming languages or scripting languages that we're working with, you can get installations for Windows, for Mac OS, for operating systems, whatever they may be. You can actually run these on any of the operating systems that you've got, and you can create them on one, run them on another, and they actually port pretty well across operating systems. Finally, what I'm going to do is I'm going to write the test script in a compiled language, which is actually going to be C in this case. Now, I'm going to include some functionality that I need. scntl.h. And I'm going to specify a main function. Now, with the other languages that we've been working with so far, we've actually got just a case where we can start programming. And in C, I actually have to specify an entry point. So in this case, I'm going to say int fd. So I'm specifying the type of the variable that I'm using, which I didn't have to do in the scripting languages before. I'm going to say test script.c, and I'm checking to see if I can open it read write. Now, if the result that I got into FD is greater than or equal to 0. And again, here are my blocks, and I'm going to use a function called printf, found the file, and again, I need my \n, and I'm going to close that block off, and I'm going to say else printf did not find the file. Again, my \n for my new line. Now I'm going to say int s equals 1, int t equals 2, and then if t, again, equal for an equivalency operator, I'm going to say they are equal, or else they are not. Close that block off, and finally, printf hello world. And the last thing I need to do here, I've actually specified my function as one that's going to return a value. That's up here with int. You can see I've got int main, my main function. That int suggests that I'm going to return a value, so I'm just going to return a 0 there. Now the next thing I need to do is I need to compile it, which again is something I didn't need to do with the scripting languages. And I'm going to say test script, and then I'm going to give it my source code here. And now I should already have the executable bit set there. So I'm just going to take a look. Sure enough, I do, because it's green. So I'm going to say .testscript found the file, they're not equal, hello world. So there are some big differences between compiled languages and scripted languages. And let's just take a look here again at the C program. A lot more structured than the scripting languages. Again, I've had to create a function, for example, and I've returned a value, and I've done some different things that I did in the scripting language. The end result is the same, it's just C works a little bit differently than the scripting languages, even though kind of syntactically they're more or less based on the C programming language. In this lesson, we're going to talk about IPv6, and we're really going to talk about IPv6 very quickly, just to show you that it's actually available. You can see INET6 address. Not a lot of people actually are using IPv6 yet, and you'll see the address looks very different from the IP address that we've been using previously. And we've got FE80, so this is in hexadecimal where the previous IP address was in decimal, and it was a dotted quad, so there were 4, which is the quad, decimal numbers that were separated by dots, so that's why we talk about dotted quad. In this case, we've got hexadecimal numbers because the IP address is so big now that we actually use hexadecimal rather than decimal to make it a little bit shorter. So we've got an IPv6 address here that's all in hexadecimal, and you'll notice we've got colons as delimiters between the blocks where previously we had dots. You'll also see colon here, which indicates there's actually zeros in between. Now, let's take a look at the functions that we've got. For ping now, if you want to ping with IPv6, you're going to ping 6. And that's a little bit different from just using ping. Now, other functions are going to have their IPv6 equivalents. Sometimes they'll have the 6 on the end. Sometimes they'll just handle the IPv6 address. Ping is definitely one of those where if you're going to ping an IPv6 address, you're going to say ping 6 to indicate that you're actually trying to do IPv6. Some of the reason for that is ICMP behaves a little bit differently in IPv6 than it did in IPv4. I actually didn't do anything to get IPv6 installed. It comes installed automatically with the more recent versions of Ubuntu. Certainly I didn't do anything here. It just automatically came up. It's there. It's in the kernel. This is actually a link local address, so I don't actually have IPv6 running on my network. And the link local is just something where your system comes up and says, hey, I don't see IPv6 on this network, so I'm going to give myself a local address just in case there's something else on the network that is IPv6 that I want to get to, even though I don't have kind of the structure of an IPv6 where the router is saying, hey, I'm your router and I'm running IPv6. Here's the network you are on. So you do have IPv6 with Linux, and it does work well, just as well as any other IPv6 implementation. If you are on a network that has IPv6, you can install Ubuntu Linux and have it just kind of come up, and it's going to work, and you're going to be fine. So Linux does have IPv6 installed natively and by default with the current versions. Let's take a quick recap of some of the things that we've covered to date. Now, we've certainly taken a look at the Ubuntu desktop and the Unity desktop that gets installed with Ubuntu, the various features that we've got of the desktop environment. For example, we've got the ability, just like you would in most graphical desktop environments, we've got things like the ability to quickly log out, suspend, restart, shut down. We've got battery, and we've got access to networking capabilities right from the desktop environment itself. We've got a button that we can get to where our programs are installed. We can see all of the applications here, for example. If I go over to the applications button down below, we can see all of the applications that are installed. Again, these are all graphical applications and work very similarly to programs that you would run under other operating systems that you may be more familiar with. We've also spent a fair bit of time in the command line environment. As I've said a couple of times anyway, this is where I think the true power of Linux actually is, and the ability to chain commands together, for example. And I can chain a number of commands together and more quickly and easily get to the information that I am really looking for. So I can be more efficient in the types of things that I'm doing. So we've spent a lot of time in the command line environment. We've set up a web server. So we've got the web server that we installed, and we actually installed WordPress. So we've got a WordPress installation here. So we've done a fair bit in terms of getting you familiar with some of the features and functions of Linux and getting you more comfortable with how Linux works. I certainly hope you've been following along as we go and doing the work side by side so you can actually get that hands-on experience. There's really not much more that's more powerful than getting your hands dirty yourself in terms of learning things. It's great to watch videos, read books, listen to somebody tell you what to do, but there's nothing that matches actually sitting here and doing the work yourself and typing it in and just sticking that information into your head and learning it by actually doing it. I hope that you've gotten some comfort with using Linux and that you will continue to use Linux as you go forward and get more and more comfortable with it. What's the next step? Well, there are a number of things you could do. You could certainly create a desktop environment for yourself and use this as your primary operating system. Or you could do some exploration with, first of all, Ubuntu. If you don't have a copy of Ubuntu and you've just been following along with these videos, you should certainly go out and get a copy of Ubuntu. There are a lot of other Linux distributions that are out there and available. You should take a look at some of them if maybe you want to learn Linux, and after looking at how Ubuntu works and how it operates, maybe you think there's another one that's going to be a little bit better for you and you still want to play with Linux. Well, I would recommend going to DistroWatch, for example. And there are a lot of Linux distributions. There are also distributions of BSD, which is another form of Unix. There's FreeBSD, for example. There's OpenBSD. There are a number of Unix-like operating systems that are out there that are going to behave very similarly to what we've talked about. Some of the look and feel is going to be a little bit different. Mint, for example, has a very different look than what we've been looking at here with Ubuntu. This, for example, is a desktop environment under Linux Mint. You can see that it looks a little bit more like Windows, for example, with the menu down here in the lower left. It doesn't really change how Linux works and how it operates in terms of what's going on underneath, all you're really doing is changing the desktop environment and the shell that you're working with. If that's something you're more comfortable with, you can certainly find Linux Mint, or you could install the desktop environment there inside Ubuntu and still make use of Ubuntu and some of the things that it does. Or, as I said, you can certainly switch to a different distribution of Linux. Once you've learned Linux and how it operates, that knowledge is going to translate across the different distributions, and you may find one that just works a little bit better in terms of the way you interact with the system. No matter what you do, though, I would highly recommend, as I've said a couple of times, getting your hands dirty and just getting in, getting this installed and playing with it for a little while, maybe making use of it as a primary desktop operating system for a bit.